Okay, good morning, everyone. Welcome to day three of Deep Learning IndabaX in Tanzania. My name is Lonny Chen. I'm working with Tanzania AI Community and Data Safari, and we're co-organizing this amazing event. The first 2 days have been fantastic. Day one was a kind of a whirlwind of nine tools built in Tanzania in various sectors. And then day two was more of a deep dive into some of the technologies used to create these tools, including small language models and retrieval augmented generation. And today, in day three, as you can see in the calendar, it's a bit of a shorter day, but we're very lucky to be kicked off by Dan Desjardins, CEO and co-founder of Distributive, and he'll talk about the launch of the compute economy. So yeah, I think without further ado, Dan Desjardins, welcome to IndabaX in Tanzania.
Hey, thank you so much, and really pleased to be here, everyone. Good morning. It's 1:30 a.m. in Kingston.
Oh, I was wondering about that. Shoot.
Oh no, but it's great. I've been having several conversations now with different groups over Africa, and the best meeting time is somewhere between 8 and 11 a.m. EAT, which is
Yeah.
always between 1 and 4 a.m.
Wow,
our time.
that's
So
rough.
turning into a
Thank
vampire.
you.
Nice to meet everyone. So my background is in computational physics. I'm one of those people or scientists who's used a lot of computing power for innovation, and I never seem to get enough of it. And that's sort of like the if you resonate with that, like as in I need more computing power to do cool stuff, and there doesn't seem to be, enough of it around, or it's hard to get it, or it's expensive because it's the cloud, or so on and so forth. Then I'm talking to you, which should be everyone. And so maybe I'll kick this off just with an interesting, thought-provoking demonstration. And then I want to get into tech, I want to get into a vision, and then I want to get into the call to action, which is we want to engage with people with a compute workload or problem, and we want to run it distributed across a whole bunch of computers across those 8 Tanzanian academic organizations and create a big, gigantic pool of shared compute for free. And not only for free, but possibly even as a revenue generator, hence compute economy. But before I make these bold claims, let me first do a thought-provoking demonstration. And then I want to dive into what this means in a broader sense. So I would like to show you my own physics research. And I'm not going to explain the math because that's not the point of this demonstration. But I think electromagnetic propulsion for Hyperloop type systems and space elevators is cool. And everyone with their own research will think that their research is cool. The thing is, modeling these electromagnetic interactions takes a lot of computing power in the same way that doing a grid search and hyperparameter tuning will take a lot of computing power. A KNN search or whatnot it can take a while. So anyway, I walk people through the math here. Don't worry about the math. The point is at the end of the day we have these two models that I need to compute over and over and over again for different parameters, and then I'm just going to plot those parameters. And let's just do that. And I'm punching in different frequencies of excitation for these coils. And I think by steps of one, yeah, that should be good. These are all the different parameters that go into my model. And when I hit compute, this little gray box or progress bar showed up, and nothing is happening right now. And that's on purpose. So you know that this progress bar isn't just a GIF or something. Now, I invite everyone in the audience to open your phone or your laptop, your computer, your Roomba vacuum cleaner, whatever device you have, open a browser tab and type dcp.live. dcp.live and hit the start button. And I will do that too, but I'm waiting for at least one person to do it. dcp.live and hit start. Lonnie, I don't know if you're able to do that. and jump in with me here?
Yep, on it. DPC.live.
DCP.
Yep,
And then if you hit start, okay, someone did it. Because if you look at my screen now, the progress bar started moving.
I got it.
And I'm doing it. I just click start with my phone, and now my phone's doing little pieces of compute. And you can see the progress bar is moving, and it's going like by chunks at a time. So what I've just done is I've taken that physics model and I've sent it to whoever pressed start there. We just created a cloud using our devices live on this call from Canada to Africa. So that's an instantaneous cloud for compute sharing. And people who are doing this right now are helping me compute through this physics problem. So my phone's in it, your devices are in it. I'll join my laptop to it. TCP.live. Now my laptop's in it. So now it's going to go real fast. And what's happening is this physics problem was split into little pieces. And the compute has been sent to in the form of slices or workload slices to the different computers that are participating. And those computers are running those computations, and then they're sending the results back to my application here. And I'll bridge the gap here between physics and AI and everything else momentarily. But does everyone, I mean, obviously the topic of distributed computing here makes a lot of sense. Lonny, any questions?
No, I guess so. The computer is happening on our devices locally.
Yeah.
Okay.
So
Huh.
I launched the job from my computer and it went to everyone's
Ah,
devices just now who participated. And I got all the results back and here they are plotted on the screen.
you know what's funny? One of my applications crashed because running out of application memory. I guess that was the reason why.
Well, if that's true, your browser tab would have crashed. Did the browser tab crash?
No, just another tool.
Interesting. So if you would have ran out of memory, your browser tab would have oomed. Uh,
Okay, maybe that's something else then. Anyway,
I think it'd be something else because the browser,
okay.
especially if you're using Chrome, there you know how it says "oh snap," that would be an exception in Chrome. So it might be I would think it's unrelated because that would have happened otherwise. But anyway, that's the right out of the gates. That's what I wanted to sort of put in everyone and talk about. Okay, look, there is an easy way to share workload and compute and whatnot. And so that's sort of like the segue into talking about some bigger things. So let's jump in.
Trial.
Oh, what was that? I heard trial. Okay. Okay, so and that's the thought-provoking experiment where we just created a cloud to share computing power amongst ourselves to do arbitrary code execution securely, which is there's a whole concept or discussion to be had around security, but I don't want to go too deep down that unless people really want to. But the concept here is what I want to share. Imagine all of the laptops and servers and computers and gaming, desktops and consoles and whatnot that could be hooked together to create a fair compute sharing network amongst yourselves. And so this project called Compute for Africa has been conceived of to do just that in Africa. So we've started this in Canada about 2 years ago, and it's growing. And now we want to bring this all over the world. And so here's the concept in a nutshell. So DCP, which is what I had everyone type in, DCP.live. DCP stands for Distributive Compute Platform, and it rhymes with TCP/IP on purpose because it is a web native computing platform, and that's why it just worked in the browser like that without needing to download or install anything. We also have screensavers and other types of workers, and we'll get to that. But the idea is a ubiquitous web native computing platform that makes it really easy to share and harness CPU and GPU computing power to create compute sharing ecosystems. Here's what since this is supposed to be a tool session, I'll talk about some API and then I'll do a little bit of a deeper example. Then I definitely want to hear some questions and then explore. But there's two flavors of API, JavaScript and Python. And then, astute people in the group here would say, wait a minute, um, Python is not web native. How does Python run in this environment? And we've done some magic with a tool called Python Monkey, which automatically runs Python in web environments and more importantly, vice versa. So you can run arbitrary JavaScript libraries and functions in Python environments and vice versa. And then that's what allows us, and then Pyodide in the backend allows us to execute arbitrary Python code and libraries. And so if you have, for example, an array or a list of inputs, which can be CSV files or frames of images or numbers or data sets or what have you. And then you have a function that you want to map to each of those inputs in the inputs list. And each map corresponds to a computation. And in our world, we call that a job slice. Each of those slices get farmed out to different nodes. The results then come back, and you just call results equals await job.exec, and boom, you now have a distributed computing cluster made up of potentially hundreds or even thousands of devices that participate in these compute sharing ecosystems. Okay, so this should look easy, hopefully, and I can show more applied examples. So the key components of DCP are a compute economy, workers, compute API, and a scheduler. Workers can be screensavers. They can be Docker workers. They can be standalone, text UI or background workers for Ubuntu. And they can be browser workers. So we have a short snippet of code that you can embed in any website. And the minute people go on that website, their compute becomes available in these shared clusters, like we just did in that deliberate demo. So those are the workers. The compute API is a set of tools that allow you to say, here are my inputs, here's my code and work function and arguments, here's arbitrary other files, go compute and then get me my results back. The scheduler makes sure that the right jobs get to the right compute groups. And then the compute economy is basically, this is the fun part, and I'll demonstrate that part in a second. That's where compute credits, which are worth actual money via PayPal right now and in the future, other payment systems. But right now, it's possible to buy and sell and trade computing power. So if nodes participate in these compute economies, if they provide more computing power than they consume, they can make money. If they consume more than they provide, then they pay. If they consume as much as they provide, it's completely offset and free. So you can see how this creates a fair, metered compute sharing economy. And the dream here is if a university or group sets up a compute ecosystem, people can share compute all day long, no problem. But it gets really exciting if that group starts producing um, solutions and applications that can be used by local industry. So if industry locally can use those compute ecosystems, it will inject money into those ecosystems that instead of going to a foreign hyperscaler or cloud provider, right? So that's the idea. Is it possible to create compute economies that bring money to local compute providers or bring more compute to local developers? in this ecosystem approach. Here's what the workers look like. And this is at Africa Nazarene University in Nairobi, this middle picture. So this is a computer lab full of computers that are idle at least half the day. And you can see there's a little screensaver, a little logo bouncing around. That's ANU's logo. And underneath it, it says Compute for ANU. And whenever the screensaver turns on, though, as it is for these 30 some computers in the lab at large, those computers go into a cluster, a DCP worker cluster that's now available to all of the students and researchers in that university. What's even more cool is that that university can share its compute with another university, and they can trade compute to augment virtually. The picture down at the bottom is the same thing, but right here in Canada. That's Sheridan College. With in total, they hooked up across multiple labs about 300 computers, and those computers were sharing compute with researchers and students at Sheridan. And the really cool thing is that Sheridan and ANU can share compute with each other across the ocean and do some really interesting collaborations that way. So we're excited about the idea of a planetary compute platform of compute sharing to accelerate research, computing, and AI, and whatever comes after that, right? We're always innovating. So these workers, they run JavaScript, WebAssembly, and WGSL or WebGPU. And I'll get into what the strengths and weaknesses of that are. But first, there are four flavors of these workers: Docker workers, standalone workers, screensaver workers, and then website workers, which is where workers can be embedded directly into websites. So what does it mean that that the workers execute JavaScript, WebAssembly, and WebGPU? People must be asking right now, well, how does that run Python? Or how does it run CUDA? Or other important questions. So I have this little graph here. Um, I mean, this is just an example of a pathway, but let's unpack this graph. The workers at the bottom are running, as I was saying, they're running Google's V8 JavaScript engine to run JavaScript and WGSS, sorry, and WebAssembly. And we've implemented Google Dawn, which runs WebGPU for GPU computing. And atop that, these are the three execution languages that can therefore run. And then on top of that, there are execution backends that exist. So for example, Pyodide, and I mentioned that earlier, Pyodide allows you to run any of the Python standard libraries and pretty much any of the standard third-party Python libraries like NumPy, SciPy, Pandas, scikit-learn, XGBoost, and others. There's also Onyx Runtime, which allows you to run inference with any model that can be converted to Onyx, which is most models. And there's TensorFlow JS. So if anyone here uses TensorFlow, there is the TensorFlow JS equivalent, which will run in V8 and in Dawn. So that's on the execution side. And what's powerful about this notion of a web stack-based compute platform is interoperability. So everyone or any device on the planet runs the web stack, right? So talk about ubiquitous interoperability with everything out there. The next big advantage is security. And I want to pause here. Web browsers and the web stack is a window from your device to arbitrary data servers serving arbitrary code from all over the world. What a concept. That's wild. So browsers are literally a vector that allow foreign code and data, arbitrary code and data from anywhere to get loaded by your computer and executed and consumed in browser. Isn't that wild? And normally that would be like a huge, dangerous thing to propose. Like if I gave you a USB key with random code on and said, here, plug this in and run it, everyone here should turn around and run. But when you're surfing the web through a web browser, that's what you're doing. You're fetching and you're executing arbitrary code and data in the context in the browser's context. And it's safe to do because we trust that Google, Apple, Microsoft, and or Mozilla, depending on which browser you use, and there are others obviously, have put billions of dollars literally over the last couple of decades making browsers fast and more importantly safe and secure to do that. So making a compute platform out of these web technologies gives you or us or people using this those two big advantages: ubiquitous interoperability and secure memory safe execution of arbitrary code that will not compromise devices. Um, Tabibu, I see you coming on and off camera. Hi. If you have a question, feel free to interrupt. Anyone can raise their hand and jump in and ask if they're curious about any of these things and want to dig in any particular direction. All right. So, and then on top of this, okay, so that's all the execution side on the bottom. On the top here, any language that cross compiles to WebAssembly or WGSL, whether it's Rust or Go or C++, Python will run via PyDide. And then you have model frameworks, right, that like scikit-learn and here, PyTorch, that's not for training, it's for inference. PyTorch models can be converted to Onyx, which can then be run in these environments, etc. And then at the top level, you have Node.js apps, web applications, and then Python applications, whether it's through Jupyter notebooks or Python scripts can deploy through this chain and then eventually execute across these workers and come back. I hope that gives people a good flavor of the technologies here and the limitations. The compute economy. This is I'm gonna get off this sort of screen here isn't very helpful. So I'm gonna go into the real world. So dcp.cloud. Welcome to the bank. So I have a lot of accounts. When you log in for the first time, if you want to try this, you'll only have the one, so it's simpler. And you can see I have a lot of these computing credits. And there's two ways to accumulate computing credits. Well, three really, but buy, earn, or transfer, or donation, or whatnot. So the obvious way is for let's say a company using an application that targets this, I'm going to buy some for $3. Credit card, punch, and this just went from 387 to 397. There's my receipt. So you can see this just jumped up here from 387 to 397 thousand compute credits. The other way I can accumulate these compute credits is to just leave my computer working. So I'm going to set this to 8 threads. I'm going to set start. And you can see now my worker is fetching workload from the scheduler. And right now it's executing it on 4 of my 8 cores. This will do CPU and GPU. And as I'm executing these slices of workload that someone else deployed, I am collecting the compute credits that they spent, and it's going into my account. Right, cool. So these compute credits are basically a unit of account. It's not a cryptocurrency. It's literally just like kilowatt hours, or it's an indication of compute, CPU seconds and GPU seconds and I/O. And I'm just slowly accumulating these and making some compute credits. And once I have these compute credits, you see it just went up by a couple of numbers here. I can either deploy workloads or I can sell. And so if I go to Dan here and I punch in some compute credits, I hit sell, this will go to my PayPal account if I actually sell this. So it's a two-sided economy, and then of course I can transfer and I can donate. So all those methods. So it's a bank for computing power. So that's the compute economy. So I'm going to come back here and we'll continue on with the slide. If there's any questions, put your hands up and ask. What I would like to do, the
Sorry,
ultimate goal.
Dan. Actually, I have a question out
Yeah,
of curiosity. Does the pricing for these, I guess, compute power, do they go up and down based on the market?
they do, and that's a marketplace supply and demand thing.
Right.
If people want to pay nothing for their compute jobs, they can actually do that. They can punch in like a number that's so close to zero, it might as well be. And if there are workers on the network willing to do that work, and it's all algorithmic and automatic, then that work will get done for next to nothing, which is effectively free. But if someone else comes along and deploys a workload for a little bit more, they'll have priority. So it's a marketplace
Huh.
compute in a sense.
It's like an outbidding kind of thing, like an auction or something.
Yeah, it's kind of like putting a rush order.
Hmm.
Um, and that's in these open clusters. And so that will allow people who provide compute and share compute amongst each other, they'll earn compute credits and then like kind of like a battery, it'll charge up. And then they can turn around and they can spend those compute credits at the same rate or over or under, and that will set the relative priority of jobs. And if everyone is doing everything approximately equal, like in a true sharing strategy, then everything sort of effectively nets out and becomes free. If people want to turn around and commercialize compute, then you can even turn a profit. There's a lot of companies out there paying AWS and Microsoft a lot of money to run their, data mining and image processing and computer vision and whatever else. Well, what if those companies were invited to run their compute on compute ecosystems like this and drive a little bit of revenue for groups, right? So this is, I'm trying to be a little disruptive here. Um, Creating compute sharing economies between universities, for example, is a great way to share compute and make more compute available for more people for effectively free. But then there's more that can be done. This can be deployed to industry to actually generate revenue and whatnot. And that's sort of like the call to action here is um, I hope I've piqued people's curiosity in the audience because what I'm looking for is a few people who want to set up a compute economy within the group and try it with a project. And then maybe we go to like the World Bank and the MasterCard Foundation and other groups and we go get some grants and then we build this up and we turn it into an initiative or a motion or a movement to unlock more and more compute amongst people and organizations for research computing, for AI, for data mining, for optimizing hospital surgical schedules, for physics, for mathematical ecology, for example, disease modeling or spreading. There's all kinds of use cases, and there's a number that we've already done. So we're getting a little bit better all the time with this, but we're looking for places to set up these compute ecosystem tests and compute share and bring the future into existence. So on this slide right here, I'm sort of sharing some very easy low-hanging fruit type of jobs. But if there's anyone in the audience here who trains random forest models, I want to talk to you because that would be a very easy one to do. Hyperparameter tuning, KNN searches, or grid searches, or lots of image processing, or machine vision, or whatever. That's if you're on the user side, because I'm looking for a use case that someone has to just show that working. And then on the flip side, yeah, the Tanzania AI group, with 8 universities, if those universities have computers lying around and they want to explore what this compute economy looks like and provide compute for just this group or this cluster of use cases, we can make that happen the same way we have in Canada, the same way we have in ANU, and we can do some pretty cool stuff together. Um, and so there you have it. If people resonate with that message, please put your email in the chat. I will collect and I will write you a message, and we're gonna get that use case that, the ones described here that fit, and we're gonna try this in collaboration with the AI Hub. And likewise, you can email me at dan@distributive.network if the idea of compute economies sounds cool. Let me know, and let's build it. Let's test it. Let's see how far this can go and see how many of the 8 we can connect and then compute share. Are there any questions
Amazing.
before yeah.
Amazing. The emails are coming in. And there's also a question from Juma asking if you can explain a little bit about OpenCV.
Yep. So
Also, I would like that too.
yeah, no, absolutely. So and I pretty much we're 30 minutes in, so that means I have a whole other 30 minutes because you generously gave me an hour. Normally I condense these to try and stay interesting in a short period of time, but now we can get into
Feel free
fun.
to chat
Yeah,
your butt off. Yeah.
I can speak for 8 hours and I
Well,
can
we have time a little bit
I can
today. Yeah.
yeah, and I can show actual code and I can show some of the other use cases we're doing, and I can take people through a tour to through all like the API, and I can actually we can do a live coding workshop too if that's of interest to people. But since you asked, we'll make it directed with your questions, and I'll just go wherever you want. So
Cool.
um, Pyodide. This is the name. Here are the names of all the packages that right now today like are immediately supported, and you can use them. If there are packages you need that are not in here, we could probably support them with a little bit of work that we would do, and then magically it would just work for you guys. So if someone says, "Hey, I have a scikit-learn project that does random forest training," um, I would say that's great because look, here's, scikit-learn is supported, and therefore we can just run scikit-learn based computations and functions and whatnot in this distributed ecosystem right now, no problem. If someone else comes along and says, I need SciPy, for scientific computing, and I have a physics demo with this later, then we're like, perfect, we got that. And then, there's pandas, and there, if you want to do like data processing and pattern matching and all kinds of stuff, Pillow for image processing. There's pandas. Here's OpenCV Python. So if you're using OpenCV Python, if you're using NumPy, etc., NumCodex, NLTK for natural language processing, hopefully people are seeing sort of this list and being like, oh yeah, no, I use those libraries, I use those libraries, NP Math, etc. Um, Light GBM, that's another one. Gradient boosting, in machine learning. Oh yeah, then there's XGBoost down here as well. That's another one, interesting one or useful one. So maybe I'll put that in the chat right now. If people in the call here have projects that use those libraries, then we can make them work almost overnight. And I'll give you an example of now everyone, okay, now you're probably okay, let's see an applied example. So there's here, let me go to Metacast. I made this one work in under 3 hours on a weekend, and now all of this can run on DCP, which is pretty sick. So Metacast is let's go see it's a Python package for broadcasting. I got to move Zoom here. Epidemiological and ecological ordinary differential equation based models over metapopulations. And it's used for modeling the spread of infectious diseases. This is very niche, as you can imagine, right? But it's a very important compute use case for modeling the spread of Zika virus or, even tuberculosis or whatever, COVID, of course. Um, but here's a question. Metacast is a Python library. Will it will it DCP? And that's the question. Will it DCP? And the answer is I don't know at first glance. Well, I do know because I got it to work. But when someone first comes to me and says, "Hey, I want to use this Python package," that wasn't in this list of these third-party libraries, right? And so what I do is I looked at the dependencies or the requirements of this package, and you can see NumPy, yes, that's in Pyodide. Pandas, yes. SciPy, yes. Then I'm like, Penguin, oh shit. And I go here, I go P, I'm like P, penguin. No, penguin is not in here. So I'm like, damn it. So maybe this library won't work, but that's not the end. And then TDQM, that's just for progress bar, so we don't care. Dask and distributed are for distributed computing. We don't care because we're using DCP instead. So basically, I just need these four things to run. These three are already available via Pydiide. This one is a big unknown. Okay, so let's continue down the rabbit hole. So I go to Penguin. Um, uh, and here's Penguin. Okay, it's another it's another Python library. So and you can see by the top here in the languages, it's all Python. So I'm thinking, what are the dependencies of Penguin? Then I'm looking at this. I'm saying, okay, NumPy, SciPy, Pandas. Those three, yes. And then I see Panda's flavor. I'm like, crap. That one isn't in this list. Right? Pandas. There's no Panda's flavor. But stats models. Here's stats models in Pydiide. So I'm kind of like, as we're like, okay, and matplotlib, that's the plot stuff, or Seaborn and matplotlib, that's the sort of visualized stuff. And we don't need to visualize stuff in the workers that are doing the work. We only need to do that in the post-processing of the results. So we don't need matplotlib or Seaborn in the workers. So again, these three are available, but sorry, these three plus this one, these four are available. It's just this one that I don't know if it's available, if we'll run it. So, okay, let's keep going. Let's see, we're going down a rabbit hole here. Git, and here it is on GitHub. So this is a really applied example, but I want everyone to see that this is kind of cool. Again, another Python package. And this one, it doesn't tell me like in the README what the dependencies are. So I just opened the init, within the source here. And it turns out that Pandas flavor only needs xarray, right? It uses built standard Python libraries and xarray. And if I go here, there's xarray. Oh my God, right? So finally, what that means, and it took us a few layers to get here. What that means is that Metacast to support this community of disease modelers research will work on DCP. Specifically, I made a little tool. Let's see, it's a little further up here. I think, yeah, here we go. I made a little tool that plots the dependencies and then color codes whether they're available or not on Pydiide and whether or not they use only Python standard libraries. So let's see if I can zoom in here. So you can see Metacast, this is what we just looked at. But here's my little tool on my computer that analyzed it, and it said, okay, Metacast uses bokeh, which is available in Pydiide. Dask, distributed, and Jupyter are grayed out because we don't need them for the computation. We don't need them for the computations, just for post-processing or the computing. And we're going to use DCP instead of Dask and distributed. NumPy Pandas, of course, is available. Penguin is in black because it's not a Pydiide package, but its dependencies are all available, all these green ones, right? And we don't need Seaborn because it's for visualization. And you can see it uses Tabulate. Tabulate is another third-party thing that's not available. It's not available in Pydiide, but it's part of the Python standard library, or it uses components that only need it. Actually, that's Tabulate is another Python GitHub sort of package, but it only uses standard Python standard library stuff, so it works. And then finally, Pandas flavor, there it is. It uses pandas and xarray, and so it works. So all in all of the dependencies here are automatically, like, it goes right to the end and it says, yeah, they're all green. And so if people want to see, I can show you this thing working on DCP. Let's take it for a spin. Jupyter Notebook. So this is the Metacast disease modeling demonstration. We're not going to read through all this, but this is stuff used by like the disease modeling agencies, Public Health Canada Agency, and others. And you know, it's the real thing, which is pretty cool. And here's the differential equations that will explain the disease spreading mechanisms. I'm not an epidemiologist, so I can't explain the science behind this, but I can talk about the compute. All of this has nothing to do with me. None of it. This is all the user's code, user's code, user's code, user's code, user's code. I'm going all the way down here to the section. Show the vaccine's efficacy, blah, 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 blah. Okay, I think I'm getting to a specific part. Here we go. This line of code here, so this LHS PRCC, I don't know what that stands for, but they're doing a sensitivity analysis. It's kind of like a grid search, actually. And so it's very similar to a grid search when you'd be doing like a hyperparameter optimization for a model. This is kind of similar in that it's computing across a parameter space, looking for what parameters create the most sensitivities for the model. So there's a lot of overlap between machine learning and what this is doing, but this is for like a very specialized statistics model. And if we run this all the way up to here, run all selected and let's run all above selected. Why not run? Yeah, here we go. And then I'm going to run this. I'm only going to do 100 computations. I think we're ready to go. So I do this. You can see here it's just running locally and it's just doing 100. But normally when you're doing these sensitivity analyses, so you can see like number of vaccinations, hospitalizations, peak hospitalizations, like this is kind of cool and useful. So just doing 100 didn't take very long, but with big models and a lot of data, and when you want to do this for like a million, that could take hours to days to compute on a single computer. Um, but check this out. Here's that same function. Okay, here's the same function, but all we had to do, and I can show you the backend here, is add platform equals DCP, and then I can put it even into a specific compute group like ANU, or I have my own compute group called Dan, and I can put into multiple compute groups simultaneously. But this uses DCP and it uses Metacast, and if I run this, let's try it. Now it's asking me for the password to deploy this job into the Dan compute group. So if I do this, to remember what it is, the job is deploying, uploading, and now deployed. Boom. Now, same thing, this progress bar is not moving unless there are nodes in the Dan compute group. So I can launch as many nodes as I want if they're not already launched. So here's another way to do it, dcp.work/Dan. And then it asks me for my password to run the work or join the compute group, and I do start. And now this computer is in the Dan compute group, and it's going to over internet fetch the packages. It's going to fetch Metacast and data and everything else, and then it's going to start working on slices of workload for that job, and then it's going to return the results. So that's it in a nutshell, of how we can take like a disease modeling project and make it work. Under the hood, maybe while this runs, what I'll do is I'll show you some of that code that allowed behind that function that actually allowed that to work. I hope this is interesting to folks and not too deep here. Lonny, let me know if I'm getting a little bit too in the weeds with this.
No, I think this is good. I mean, it is meant to get deep technically for Indaba, so it's good to get in sometimes and look at
So here,
code.
so then here we are in some deep code here. This is the script LHS and PRCC that where that LHS and PRCC function were called. And here they're doing like a Latin hypercube, to do the search space. So that's for the parameters, and they're defining the boundaries, etc. I don't want to, we're going to sort of go through this in parallel, diagonally. We're not going to get too deep, but here's a LHS PRCC function that I called in the Jupyter notebook. And you can see platform by default, I mean, it's none, you'd run it serially, but if it's defined as DCP and if the compute groups are defined, this is everything that will run. So here's all the stuff that basically will, if, else if, run serially, run on DCP, or run on a different distributed computing platform. You can make it do whatever you want. So if you're going to run it, so for parameter in the parameter space, like do something, etc., you can see this is where it does it serially. So if people in these groups have written code that looks like this is such a beautiful, I'm going to connect this to the deck I showed right at the beginning. Look at this. For each of the parameters, in all of the parameters you want to run, or all of the hyperparameters you want to explore, or all the data sets you want to compute, or all the whatever, for input of inputs, results.append, run your expensive compute function on that parameter, and then and then store the results. Hopefully everyone here sees that this is a serial operation, right? And that's what can be distributed. I want to come back to the really quickly. Remember in this deck earlier, maybe not, but to go back to it real quick. Remember this, where I was saying, if you have a workload somewhere where you have inputs and a function, you can basically write this DCP compute for, it's a distributed for loop. It will apply that function to all those inputs in parallel. That's the parallel job. So going back to what we were just looking at, if you have a job, if you've written a Python script that does this sort of results, equals empty array, and then for each of the computations, do them all and then store the result. If you have code or a problem that kind of looks like that, you can rewrite it. I'm going to skip that. You can rewrite it in DCP. So rather than run it serially, you can run it in parallel. These two lines of code just pull in the DCP library. And then this is a little bit more, this is just for this has nothing to do with DCP. This is just like the password, putting in the password for the compute group. But check this out. Job.modules, we're telling the job it needs NumPy, SciPy, pandas, and Xarray. I'm even uploading in this file system Metacast, Penguin, Tabulate, and Pandas flavor. If you remember that from earlier, I was showing you, hey, I can upload all these packages and it will just work. Is that cool? So I'm providing all the modules required for the job. And then everything, this is just a progress bar. All this code is it's noise. Here's where the only thing that has to do with DCP really is, I think I skipped past it because it's so short. Where is it? Here. This is literally the only line of code that's important. The job is to take compute.for and match the model run method, which is the LHS PRCC, so the function, match it or map it to all the parameters, and then there's a list of arguments. I mean, this is just magic. Take the function, the expensive computational function, and all of the job arguments, so data sets or integers or whatever, and then map it to all of the parameters or the inputs, and that's the parallel job. And then the rest of this is just crap. This is just like getting a password for a compute group. This is feeding it the files and the modules that are needed. And this is just creating a progress bar. So it's just boilerplate. And then finally, these are the only two lines of code that matter. Job.execute, results equals job.wait. Isn't that wild? So this will automatically take that job and run it over arbitrary computers everywhere. And you can see, sorry, I guess you didn't see this, but 40 slices were executed here. and then 40 slices were executed somewhere else. And you can see, I guess, sorry, I guess you didn't see it happen, but I come back to this later, but the job is 100% complete here, and it worked distributed across the Dan compute group with workers in it. And so what I'd like to do is create the AI Tanzania or the SUA Hub compute group, right? Or any compute group that people want. And then all of a sudden you can share compute just like this. So that was a very applied demonstration of how you can get even a very sophisticated disease modeling, parameter search application and set of applications and even modules that are not supported directly by Pyodide, even if they're not directly supported by Pyodide, if the libraries wrap Pyodide supported libraries, then it will still work, as in this case. I want to show you an example where it doesn't, and then we're almost at time. So I'm gonna, oh, I already cleared. Maybe I can't get up there. I'll shut down the Jupyter. Yes. Where was the rest of my stuff? Here we go. Package, Metacast. So this is the dependency explorer. So again, as proof, we just did the live demonstration. Metacast, which is not supported by Pyodide, depends on packages that are supported at the end of the day by Pyodide, which means it will all work. But let's do something else. There's another package that I think is phenomenal that I want to, and the reason I built this tool is because I want to get this online. So this is called EconML. EconML is for federated learning, right? Which is really exciting because now you can create clusters of clusters with independent data sets for precision medicine and genomics and some really cool, important bioinformatics workloads, like spreading compute across multiple hospitals to analyze data without moving data outside of the hospital, but still being able to launch a job across multiple hospitals and then fusing the results together. So we're doing something like this. We're starting with UHN, which is the top medical institute in Canada. And if I can do federated learning, it would be pretty epic. And look at this. Everything is supported except for this one library called SHAP, which almost works completely on out of the box, except it needs Numba. Numba is not supported yet. However, Numba is not necessarily required. So in the next coming days, I'm going to strip out Numba, and then I'm going to see if I can get EconML to run on DCP without Numba. And because it's going to execute in WebAssembly, I should get some of those performance speedups because it's executed in WebAssembly, which is a WebAssembly web, equivalent of bytecode that's compiled in fast. And so Numba is designed to speed up Python computations. But because we're not actually executing Python, we're actually executing WebAssembly transparently in the background. It's not going to be as fast as Numba, but it's going to be way faster than just pure Python without Numba, if you get my drift. Anyway, that was a lot of talking, but to wrap everything up, I guess now that we're at 226, I want to build compute economies all over the world. I want to create these clusters where people could share compute and accelerate their research and their whatnot. So I am looking for use cases. If someone here in all the demos that we showed have either an existing script or one that they want to build that would try this, I want to talk to you. And so thank you for your emails, and do share your emails in the chat if someone has something that looks like it would work. Let's set it up. And I want to talk to the university organizations. I want to create a compute group, to share computing power. And I want to run those use cases on those compute groups. And then I want together as a community, maybe we can go get some money from World Bank or these other big institutions and, build really cool projects and create revenue generating ecosystems, or at least not just revenue generating, but more importantly, sustainable, so at least that it can sort of power itself and generate enough revenue to sponsor more workshops, and more community engagement and more stuff, and propel into the future and not just give all our money to Jeff Bezos or at AWS. So thank you very much. I hope people thought that was the exciting or interesting. And if you want to help join the compute economy, if you have a use case or if you have computers or both, um, write to me, connect on LinkedIn or send me an email and let's get started because I think this could be pretty cool. Thank you.
Wow, amazing. Thanks, Dan. I mean, this really is a game changer, right? For people who need compute and can't get it otherwise.
Thank you.
I hope everyone sending their emails if they're interested. We have some in the chat. We do have one question in the chat from Juma. Do you see it, Dan? Or can I
I
share it for
do,
you?
yes, yes. And that's an excellent question. So in distributed computing networks, how do we make sure that people, organizations sharing their computing power are rewarded fairly? That's the When was it? That was posted at 219. I showed like the compute, the bank. I'll go back to it because that's an excellent question. So when I deploy my job, now I'll open up another Python example real quick. Do I have time to go over? Is that okay, Lonny? I don't want to.
You do. I have an hour, but I won't take that much time. So yeah, feel free to eat into my time because I don't need that much.
Okay, but I'll still be respectful. I'm
No
opening
worries.
up. Where's my physics at? Or is it benchmark? Or did I call it demos? I just got to find where, because I have way too many things here. Benchmark, here we go. Physics. So here's another Python example, and I like this one because it's clean and I wrote it. So it's a lot easier to sort of explain, obviously, when you wrote the code yourself. So here's the two same things again, import DCP, DCP.init. Here's the list of inputs, right? So I'm just creating a linspace from 50 to 300 megahertz. These are frequencies, and I'm doing 30 of them. So this is basically a list of 30 frequencies that go between 50 and 300 megahertz. All right, just remember freak. Then the work function, this is V for voltage, and then there's a whole bunch of inputs. This first one, F, is a frequency from this list of frequencies. And then the rest of this are just their satellite antenna dimensions, right? Or whatever, they're just inputs. It could be whatever, data sets, numbers, and arguments. Then you can see in my function, I'm importing a lot of these for people who've done like some heavy math. These are some pretty scary, hyperbolic Bessel, modified Bessel functions of the first and second kind. And like, this is some nasty stuff. And nastier than that is this one here. So n-dimensional numerical integration. This is computationally expensive, right? Running these integrals. So this is what we're going to use in this function called V, or voltage. And the rest of this, these correspond to equations that I could show you, but it's kind of annoying. But you can see I'm using all these Bessel functions and blah, 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 blah. And there's a math model that's what I do in physics. I make math models. Here, this is a math model just written into Python code that I then want to compute. And here's where the computations get expensive. You can see that I'm doing this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 of these. I'm making 12 calls to this three-dimensional numerical integration routine. And each of these take several seconds. And by several seconds, I mean they each take about, I don't know, 15, 20 seconds. And there's 12 of them just here per frequency. So if I want to do a frequency sweep of, let's say, 1,000 frequencies, then that will take all day. It will take all day on my computer. But if I spread it out across 1,000 computers, it'll all be done in 2 minutes, right? Okay, so that's the function V, and it
Hmm.
returns the total voltage. And then here's
Hmm.
all the job arguments. Remember all those numbers I said in the function? So that's the Vx, Vy, everything else. So then I just provide the args. And look how clean this is. job equals DCP compute.for, the list of frequencies, the work function, and the arguments. And that's it. And then the job requires NumPy and SciPy. I can put it into the University of Alberta compute group or the Dan compute group or whatever else. I can give it a name. And then I can wire up event listeners. This is all optional, but this, again, this is just like this is just a progress bar that I wired up. Make progress bar. Well, you don't need this. All this code could be deleted and it would work just the same. And job.exec and results equals job.wait. That's all. Now, why did I show everyone this all over again? And it has nothing to do with the question that was asked, which is how do workers get fairly compensated? This this number in here, if I don't put it, like the other demo I showed you, there was nothing in those brackets. Okay. When there's nothing in those brackets, it is the market value for compute. And you asked that, Lonny, earlier, like, oh, so it's a marketplace effect, and you're correct. So when people are deploying jobs and matching back and forth, it's evaluating how much a CPU second is worth, a reference CPU second, because not all CPUs are equal, a reference GPU, and then input and output.
Yeah.
Exactly. And so if you don't write anything in here, it will just use the current market rate for the compute for this job, and it will debit from your account the amount of compute credits that corresponds to that market rate. And I think I was showing that earlier. So I have my account, I have a bunch of these compute credits. So it will pull out of that account the compute credits required to compute that job at market rate. If, on the other hand, you're like, I'm fine if this job takes all week, you can deliberately do this. Okay. So 0.001 compute credits is almost nothing. Why? Because 0.0, okay, one compute credit equals, oh wait, I'm going to put this as a string. One compute credit equals 0.0003171 USD. So 0.001 compute credits here per slice really means I think that's 3/100,000ths of a dollar. Okay. This is so freaking
To the
cheap.
negatives.
Yeah. So, or 3 millionths of a dollar. This is cheap, right? It's effectively free. So
Yeah.
if someone does this, then they can deploy their work for pretty much nothing. And if
It just takes longer though, right, Dan? Is it?
Well, if no one else is using the cluster, then the workload will get done right away anyway,
Okay. Just depends on,
right?
okay. Wow.
Right. Now, see. So if the group, if this whole group, if everyone sets up a worker and there's only one job that someone deploys and they're deploying it for next to nothing, and the workers have nothing else to work on, they'll work on it. And
Okay.
so that the job deployer gets that job for almost free, and the workers, they're not getting paid much because this person isn't offering to pay much. But then again, the workers have nothing else to work on, so they might as well work on this, and it's part of this ecosystem. However, if someone else deploys a job, okay, so let's say I deploy this really garbage cheap job because I'm cheap and I don't want to pay any compute credits. But you come along, Loney, and you do this. Just delete a zero. Okay, so all of a sudden it goes to this. Well, now you're offering 10 times as much. It's still practically nothing, right? But you'll have
10 times nothing.
You'll
Right.
have a 10-to-1 ratio. So 10 plus 1 equals 11. So of all the workers, 1/11th of them will go to me and 10/11ths of them will go to you.
Hmm.
Okay, so it's like a partition. No one needs to know how this works, but that's the fair mechanism, is that people proportional to how much they're offering of these compute credits, which by the way you can earn, so it makes it free anyway. Um, people can spend their credits faster if they want priority, or they can go slower. And if everyone offers the same relative amounts of the market value, so i.e., just not putting anything in here, then everyone will have an equal proportion of the available resources. Isn't that nice? And that just
Oh, fascinating.
corresponds to the default, which is you don't have to write anything. So that and now the exciting thing is if this takes off and there's a local car insurance company that wants to digitize their paper records. Okay, I'm using a real life example. If there's a local car insurance company that has paper records and they want to digitize them, that means they need to do a lot of OCR, optical character recognition, analyze all those PDFs, and then turn them to searchable text documents. So, we could work together as a team here to create or to get an ML model, an OCR model, convert it to Onyx, load it onto DCP, and then do distributed OCR inferencing to convert scanned paper documents into text documents, and then offer that as a service to that insurance company. And the compute happens on AI Tanzania's computers, and that will generate actual revenue to the group, right?
Hmm.
And so if you lower the cost of compute, you go to that insurance company and say, look, by running your OCR on us, you're getting cheaper compute than AWS. We're getting some revenue for our group, which allows us to buy computers or do education workshops or do stuff. And then that's how you can create an actual revenue generating compute economy.
Hmm. So it's a win-win-win for everyone,
That
except
that's that
Amazon.
that's the goal. Yeah, creating these win-win
Hmm.
wins. And of course, and we take a little bit of that too. I mean, we're the orchestrators, so we take a piece, the compute
Yep.
providers take a piece,
Interesting.
application providers take a piece. And so if everyone gets a piece of this pie, that's what you call a digital economy. An
Yeah.
economy where different people,
Cool.
different independent parties come together and exchange goods and services to rise, raise the tide that raises all ships. And so
Hmm.
that's the notion here, but from a compute perspective. So anyway, if people think,
Nice.
okay, so that's how workers get fair. Should I stop now?
One question from Ezra, which I also had a similar question about security and privacy. Can you read that? Good one,
Absolutely.
right? Important one.
It's no kidding. It's an important one, and I kind of glossed over it at the beginning when I
I
was
missed
talking
it.
about the web stack, right? And so I'll revisit that now because now people will recall what I said at the beginning, and it'll all make sense.
Yeah.
So
And we are recording this. We're going to post on YouTube, so they'll be able to review it later. I'll
okay,
send you the link.
okay, cool. And for the record, if anyone wants to talk security, like specifics, and go really right down the rabbit hole, like I will have a 6 hour follow-on, call with just security, at a later date if everyone wants. I'm happy to do
We can
follow-up.
find you on LinkedIn. Is that okay?
Yeah, I would
Yeah.
link absolutely. I'm easy to find on LinkedIn here. Let
I already
me,
stalked you. Yeah.
yeah, just throw it in the chat if you don't mind while I
I
talk
will right
security.
now. Yeah.
So I was saying earlier that web browsers are, these are windows from your devices to the world, right? Whenever you're surfing the web, if you Google, I don't know, alien autopsy, right, in Google, and you click on, there's some weird links that come up, you're going to be hitting data servers, God knows where on the world, and you're going to be fetching CSS, JavaScript, HTML and data and all kinds of stuff from like who knows where, so some data servers wherever. And then you're going to execute that within your browser and you're going to consume that content. So browsers are literally built for executing untrusted content served from who knows where around the world, but securely on your computer, right? That's what surfing the web is. And that's crazy. It really is. Um, and the only reason it's possible is because literally billions of dollars have been poured into making the web stack secure and performant by the likes of
Mm,
Google, Apple, Microsoft, and Mozilla over the last several decades.
okay.
Crazy, right? And I can talk about that. So specifically inside if let's say, assume most people here are using Chrome or Safari or whatever, Chrome, in the heart of Chrome, the JavaScript engine that's doing the compute is called V8. It's obviously by Google. And it is a memory safe environment, super, super, super sandboxed environment that does the code execution itself. And in order to deploy, for example, malicious code that could escape the V8 engine, there's a name for this. It's called browser escape. Okay. And it's something that maybe potentially only nation states are capable of doing because it's extremely hard. Why? Because there are 6 billion devices around the world that run Chrome or Safari or Firefox or whatever. Um, and therefore, every hacker on the planet has tried to do browser escape because that's how you would, I mean, every hospital computer, every device in the world runs a browser. So what an attractive target to try to hack. Because if you can escape that, if you can come in through the browser, through a Zoom call, and then get onto the computer, that's right. Then you can access every device on the planet.
We're all screwed, yeah.
Yeah, we're all screwed. So and for that reason, it's really hard to do that. In fact, it's so you need like in fact the only in my recent memory um, of that being possible was through the Spectre and Meltdown class of attack, if anyone remembers that Spectre and Meltdown. And that wasn't just affecting browsers. That was literally the silicon on the chips themselves that had like a really wild, the way they were like,
Really?
oh, it was it was such a G, it
The
was a
hardware
well, it was a
or
hardware level.
firmware?
It was sorry, it was a firmware level problem because of the way that they were forcing sort of memory. Like I'm not like the security analyst. I'm gonna probably say it wrong, so I won't attempt to. But it was so deep and it was so elegant that it wasn't just affecting browsers; it was affecting everything, right? So it wasn't
Wow.
it wasn't a browser vulnerability. I guess what I'm saying is that it wasn't a browser vulnerability. It you could exploit it, but it was much deeper than that, right? Now, within days, Google put out a patch for Chrome against the Spectre Meltdown class of attack, right? And so our idea for this compute platform or this compute technology that runs on the web stack benefits, inherits all of the security of the web stack because it's built on it.
Okay.
And
All built
and
in for you then.
yeah, and I I'm one of the few startups that gets to say I have 2,000 security analysts working for me for free and they're paid for by Google because they're
Mm,
all the Google security analysts, they are working to patch security vulnerabilities that come up in Chrome as soon as they come up, if they come up, right?
mm.
And because I'm built on their standards and their technology, I inherit those patches immediately. So, we're standing on the shoulders of giants with this compute technology, and we inherit their security for free because it's built on it. So they rolled out a post-quantum cryptography sort of protocol that you can opt in or use behind Chrome, I think last June. And so now we have that too. So it's kind of cool. Imagine that. So a compute platform that evolves in lockstep with the major web giants. And so then I don't know if that was a good enough answer to the security data privacy question, but yeah,
Yeah.
we like to say that we're built on the same standards that enable online banking. And so if you trust online banking, you know,
Hmm. Yeah. That's a good answer in a nutshell.
yeah.
If you trust that. Hmm. Okay, nice. Yeah, thanks, Ezra. I hope that answers the question. Anyone else? Uh, y- uh, if not, then I guess I also have one. What was it actually? Um, h- is there much downtime in the system? Could a job get stuck even if you have enough funds in your account? That's one. And second one is, what if your funds run out midway through the job? Is that possible, or is it just
Yes. So first question. um, your job, which is that function mapped to the inputs, and those are all job slices, right? So if you have like 1,000 job slices, and it's all automatically sort of sliced and sent out in the way you articulate it, each of those slices hit the scheduler and then they get sent to workers. If someone just throws their computer out the window because they it pissed them off for the very last time, that slice times out at the scheduler level and then respawns somewhere else. So,
okay?
so the job itself, once deployed, will self-heal. I don't
You
like
don't
that.
lose jobs then.
Yeah, jobs and slices don't get lost. They just bounce around and respawn if they time out because a computer was shut off
Okay.
or because
We shouldn't care. Like, it just happen.
yeah, and users shouldn't have to care about that. Basically, like my dream I'm like the first user of this platform as a physicist. I just wanted to say, here's my code, here's my data, go away, finish,
Yep.
and give me my results. And I don't
Yep.
care if it runs on a fridge or like this, the
Or
nonsense.
where. Yeah.
Well, when you go to the cloud today and there's like 50 pages of instance types and this and that, and you have to choose them, and then you have to DevOps and choose the right region, the right this and the right that, and it's just
I hate
it's
that stuff actually.
well, yeah, it's
Respect to the
DevOps.
DevOps people, but
That's
yeah,
it. It's a DevOps thing. And why does DevOps exist? So, like I'm a scientist, I'm a user. I want my results, and the compute infrastructure is here. DevOps is like in between. It's a layer that now exists in between that got between me and the hardware that's actually doing my work, right? Like why? Well, because the cloud industry and the tools that exist, like anyone set up a Kubernetes cluster before?
heard of it.
You heard of it, eh? What a pain in the
Eh,
frigging butt.
Is it?
You know, it's nuts. You can do a PhD in DevOps, right? It's just nuts. And so we wanted to get rid of all of that crap and create an API that allows users, programmers, to say, here's my code, here's my data, go away, come back when the results are done. And I don't care if it's the C5 2x large instance in US, Oregon, East or West or, you
Yeah.
know, or whatever. Like it doesn't matter. Just give me my results. So
Yeah.
in the same note, we want to hook up, 1,000 computers, across, 8 universities and then um, securely compute share and just make it accessible with compute.4. There we go.
Nice. Nice. Okay, good answer. And if a group in Tanzania, a hub or sample, for example, wants to write a proposal with you, to World Bank or some one of the funders, would you be open to that as a
Absolutely.
partner,
That's
a
my point.
consortium thing?
Totally. I mean, like we can go after money to do that. So here's what I think is the easiest or the best way to do that. Uh, I copied the emails that were put in the chat. If there's more people with use cases that resonated with like random forest or something low hanging fruit, whatever, um, I want to put my I want to meet someone with a use case from the group that would work like with low effort, because then we can point at it working, right? And so in an application to World Bank or to whoever, some philanthropic sponsor, we could say, here's this cool concept. And I have lots of pre-written material about the concept. But then you can say, and here is this use case, this prototype small use case that we ran as a pilot example, and it worked. And now we want to do this precision medicine or hospital or manufacturing or energy or what some other like something much bigger that requires going after a big funding grant. So whenever you go after big funding grants, it's good to be able to point at something that worked.
Credibility.
Yeah.
Hmm.
So that's why I have the emails in the list here, and anyone else add your emails to the chat if you think you have a use case that fit the descriptions that I was talking about. Because if we can get something simple up and running, and with enough credibility, and operationalize, and then we can basically say, now we want to do this at scale, and for these use cases or whatever. Like I would love to build an LLM, a small LLM tuning facility on top of DCP. That doesn't exist right now, so nobody ask me for that right now, but we could build it together,
You need to
right?
talk to some of the people who were on yesterday who are building these SLMs. Yeah.
Right. Well, I'm talking about building the tools that tune the SLMs.
Yeah. Yeah.
Right? I would love to generate a WebAssembly and web GPU library that runs distributed to do this sort of this training for these SLMs. That doesn't exist right now. It exists, but they're in other languages like CUDA, right? Or TensorFlow federated or whatever, or PyTorch. So all these algorithms exist, they're just not written to target WebAssembly and web GPU. So that could be an epic, big team project, is to get money to basically take already developed code and port it to WebAssembly and web GPU, and then all of a sudden it would work in this type of system. And then once it works for everyone everywhere on the planet. Yeah, yeah.
Awesome.
But
Nice, Dan.
went over here. But
Yep. Thanks, Dan. Anyone else? No last questions? No? Okay. All right. Thanks, Dan. Really appreciate that time. That was you have great energy for 2:30 in the morning. Um, and thanks everyone for your questions in the chat as well. Yeah, I think Dan, you're very open to working with people here, so I think that's really we're really grateful for that. That's why we're doing these kind of events, right?
Absolutely. Thank you so much. And over to you. And
Thanks.
anyone can yeah, and anyone can reach out to me here. I'll just put my email back in the network.
Yep.
Anyone can reach out, LinkedIn or email, and let's get something up and running. Cheers,
Yep.
everyone. Great meeting, everyone. Bye-bye.
Have a nice night. Take
Thank you.
care. Okay, nice. Okay. That was excellent. Yes. Okay, so 9:54. Now it's actually time for Data Safari to talk about what we do. So I'm Lonny Chen, again, the founder of Data Safari. I work with a team of, our team is about 11 young Tanzanians who are passionate about data science and AI education. Some of them are online. We have Stuart, Agnes, Carolina is the team of Morogoro. We also have other people, Jonas, Brenda, Zainabu, and other places. But we will be talking about AI literacy education, and we're going to be demoing the tool that we use called Orange Data Mining. So let me share. Do you guys see my screen? I think so, right? Okay, so we presented this actually at the Tanzania AI Forum 2 days ago. And what we are really passionate about is called AI literacy education. And we think it should be started early, it should be inclusive to all different people. And it should be not just for IT people or coders or AI ML engineers, but anyone studying anything should learn about how AI works in the fundamental level. So what we did, second here. So let's just maybe define AI literacy. So there is using AI for education, which is of course very important, but it's also education about how AI works at a fundamental level, including the importance of training data, how the algorithms work, ethics, responsible AI, and fairness, representation, that kind of thing. And that's all kind of under AI literacy. Different groups, different places around the world have different definitions, but they kind of all talk about similar things, right? From African Union, UNESCO, and AI for K-12 USA. So why early inclusive? Some takeaways from the first day of the forum, which happened again a couple of days ago, is the importance of building human capital, right? Growing the tech talent pool in Tanzania. Of course, having strong university programs are essential, but why not start students learning at secondary school level, even primary school level? It's possible. People are doing it. It just is going to be much more beneficial to start as early as possible. The actual exercise of doing that builds critical thinking skills. Data can be problematic. So how do we fix the data? How do we make it more fair, more representative? We need people to build tools here. And so instead of adopting tools, building our own tools. And so getting people started early on that kind of thinking will be much beneficial. And of course, AI already affects everyone, right? Um, AI, people are using AI on their phones. AI is kind of giving them recommendations in different programs, but it also affects people even who don't have devices. For example, resource allocations, project allocations, those decisions could be made by a machine learning model. People may not even know that, but that can be happening. So it's really important for everyone in society to understand, at least at a fundamental level, how this works, what kind of biases there could be, that kind of thing. So what we did was pilot AI Wizards. It's a program at university level. We piloted at SUA. It was an 8-week program, once a week, every Saturday morning, with some really amazing students. We had an amazing group of about 34 graduates, some of them who are online here today, mostly at SUA Hub. And what we did is we started with intuition of how these models work, right? So the concept itself. So if you look at the lower bottom here, this is a SVM. SVM is all about boundaries between different classes, right? So we gave everyone a sticky note, either a green one for being a healthy cassava plant or red meaning a sick cassava plant. And we asked people, how would you draw a line between those two groups with minimizing the misclassifications, which is kind of in a very simple way how SVM works, right? So people can get build the intuitive understanding of, okay, this is how the model works. This is what we're trying to do. We're trying to classify. minimize the error rates. There's some different considerations, of course. So that's just kind of the first thing we do, right? So people kind of understand it's just in a very inclusive way. And by the way, the students we have were from all over different courses, a lot of environmental science management students, rural development, et cetera, et cetera. We had some IT people, mostly from Zoom Bay, but it was not just IT, so it was really open to everyone, and that's really what we want to do here. Once we did the physical exercise, we go to like a pen and paper activity. So you can see on the next to concept flow, they look on a graph paper. We give them some data points. We ask them to draw a line, and then we ask them to, which is basically the model itself. That's the modeling, right, for SVM. And then we give them some test data to see how well it does with new unseen data, and they can kind of see the trade-offs of underfitting, overfitting, generalization, that kind of thing. It's kind of explained in this kind of way, right? Then we have Madam Carolina here discussing some concepts of how SVM works in some technical detail, not like super deep, but some intuition. And then on the top right, we use this tool called Orange Data Mining. It's not from, we didn't build it. It's from the University of, from a university in Slovenia in Europe. But it is basically a free offline tool. You can just download it. You don't need to be online. You run it on your computer, and it's no code or low code. So you will see in detail a bit later, but it's all about these widgets, these kind of, I don't know what to call them, kidude, these things that you can just put on your screen. It's all drag and drop, and each widget is kind of like a function, maybe in scikit-learn, and you just run that function, and then you link with different widgets, and then you create your whole workflow, right? So it's really a fantastic tool and enable a lot of learning quickly without getting into the details of coding and environments and that kind of thing. So just our whole ethos was to engage students in a really inclusive way, and we got really good feedback. People really enjoyed these kind of approaches. So yeah, some ideas of in the big picture of how we can maybe even bring this to younger levels is this is kind of more of an advocacy thing, right? So progressing from very simple things at primary school level to more difficult at secondary, and then on and on and on, integrating data and AI into different subjects like, for example, like civics or history. We can have data sets there. People can teach about that using local data that you can collect in your own environment, and of course, upskilling teachers. Okay, so that's the presentation there from the forum. A little bit of background on what we're doing. I'm going to go straight to how we teach. So um, because we did a lot, and I hope everyone can hear me. Yeah, I think everyone can hear me. Because we did talked a lot during IndabaX about language models, right? And embeddings. So I'll go straight to this section. One of the later on sessions is talking about word embeddings and how they represent meaning. Because of course, most people got into AI with ChatGPT. So we really wanted people to understand how ChatGPT works at a fundamental level. So we start with just the concept of similarity, and we give them exercise about meaning in one dimension. So all these different words: happy, healthy, bad, fine, good, grateful, fantastic, tired, late, sad. We ask everyone to put all these words on a scale of sentiment. So something like happy could be an 8 in terms of how positive it is. Healthy could be maybe 7. Bad is probably negative something. Fine is maybe like 3. It's just, and everyone debates it. It's very engaging, participatory. And that's basically an embedding in one dimension, right, of words. And then they can use it to do some sentiment analysis on some sentences. Um, and then we go to 2 dimensions. So in terms of meaning of living, like how alive something is, and color, how dark or light something is, we give them, words like apple, orange, cat, dog. And we do the exercise. Same thing for something like Asian income. And then we kind of try to extrapolate that to like, okay, you can do this in 3 dimensions or in many, many, which is what really happens. But the idea is kind of there, right? So, and we talk a bit about how it gets trained. We won't get through that. That's a bit technical for now. And then how they're actually used. They get trained from this way. And then we go to Orange and we do an interactive activity. So let me just try to do that right now. Okay. Let me find my Orange. I'll show my whole desktop actually, maybe. You guys can see it's orange. Okay, so here's orange. Again, you can all download this. It's all, yeah, I can probably show you. It's just orange data mining. Yeah, just download it. It's not too big, and you install it on your laptop. Really simple. Okay, so one quick activity that we do here is it does require Python. Is we ask them if how similar can you get another word from another word? So that's how kind of helps some of the embeddings are based on, right? So for example, mother and mother, if you run this script, you get a 1.0. So they're exactly similar. We ask them, okay, what other words are similar to mother, as similar as possible? So does anyone have any ideas in the chat that we can try? Who can get, so maybe we can make this a bit interactive and see who can get the best score. Again, I know most people here are very knowledgeable about this kind of thing, but kind of imagine if you're a university student who does not have a background in AI, not a technical person, but want to understand how it works at some basic level. This is how we introduce it to the general population. Anyone have ideas of another word to try besides mother? You can write in the chats or just speak it. Mom, thank you. Okay, mom. That's smart. Mom gets 7.73. Okay. Okay, I'm gonna just copy paste. Thank you for your comments. This is fun. I'm glad we're interacting. School and teacher. Yep, let's get at least 5. 2 more, please. Who can get the best, closest, highest score? Anyone else? I'll wait a minute. No prizes, unfortunately, but mama, okay. This is English, by the way, so I'm not, maybe it might be there. We'll see. One more. Doctor. Yeah, okay, I see. Yep. Okay. Thank you. Office and table. Ah, that's the next one. Thanks, Omari. Okay, so which one is the highest one? Let's see. The highest similarity is actually mom. Makes sense. Mama is close, of course, it makes sense. Doctor is zero point 0.4. That's good news over teacher and school. Okay, so yeah, this is the kind of thing that we do with students. Another example is office. Yeah, office is trickier. Let's try office. Who can give me a similar word to office? Garibuni. This is a bit trickier. Okay, ideas for office? Table. I'll use table. Anyone else? Space. Yeah, thank you. Employee. Thanks, Udon. One more, please. Building. Yeah, I like that. Work. Lovely. This is great. Um, yeah. I think, yeah, I think yeah, let's see. Who wins? Um, Building wins. So congratulations, Liston. Yeah, building is 0.33, followed by employee, space, work, and then table. Yeah. So yeah, so students can start to get the idea of computer. I'm not sure. Yeah, maybe. Yeah, that's up there. So yeah, students get the idea of how embeddings work. That basically there's meaning from words in some numerical form based on vectors, right? Okay, great. So that's the first activity that we do with students. Thanks everyone for participation. Hope that keeps people engaged. The next one is actually seeing these embeddings in some space. So we do tell them that I think we're using Word2Vec. So Word2Vec is like 300 dimensions, right? It's a lot. So here we connect this to the data table. I hope this works. Yeah. So these are all, so here you can see the actual embeddings, right? And we talk a lot about embeddings in different presentations from day one, day two, but what are these really, right? So it's kind of good to see them, you know? What does it mean? We don't know. But a word like said has basically 300 numbers, right? And it's really cool that Orange just gives us a data table to look at the whole, it's basically a data set. And we tell the students we don't really know what these mean, unlike the simple examples, but they do mean something, right? Uh, okay. So from this, an even cooler thing is TSNE, which simplifies like any number of dimensions to two, just so it's visible. Of course, lots of simplification there, but so you connect data table to TSNE. Uh-oh, what happened? Ah, yeah. So it's about widgets and connections, right? So I got to get the link right. Uh, let's wait a little bit. It needs to generate the 2D graph. Let me know if anyone has any questions about how this all works, but for now we'll wait. But as you can see, pictures speak 1,000 words, right? So instead of just explaining things or giving them terminology, they actually can see it and play with it in their laptop, which is just a huge win and makes it just more fun, accessible, memorable, I think. Yeah. Okay. Barakidogo, it's coming. And then we can zoom in this 2D space, simplified 2D space, and look for groupings, right? And the groupings should make sense. Apple, well, we'll see. I'm also only taking the top, like the first 50K words. I don't think I'm taking all of the word Vec, but close, or not close, but some. Almost there. Okay, great. So what is this? Wow, look at this. These are all, well, 50,000 words of word Vec. And let's just zoom in somewhere. I don't know. Let's look for some groupings. Oh, wait. I don't see the dude, there's okay. Okay. So sports memorabilia, collectibles, entree. Let's for something more interesting. What's this? Yeah, digits close together, right? Makes sense. Here, how about this one? LED watt projectors. Normally, May, that kind of thing. So yeah, we just give students a chance to like just zoom around and understand what's happening. To know that words are basically represented in numbers, right? And that's how that's how anything with NLP works in general. Nowadays, some abbreviations, I don't know, airlines. Oh, here you go. Yeah, Mommy, economy, macroeconomic underscore with no underscore, remittance. I mean, yeah, you can just go on forever and just kind of look for groups of words and see why they're together. And usually they make sense. Not always. I mean, remember it's trained on some specific data, so it depends on what's in the training data. But yeah, it's a pretty cool. I think it's really neat to do this. Okay. Any questions so far? If not, the next session that we go through, actually the last session of this program is going from static embeddings to, of course, contextual, right? That's how we go to the things like attention. So we give them, so we talk about this classic, leaves. So we ask them, should the embedding of a word change depending on the context? So leaves, right? It can be leaves, Majani, leaves on a tree will have fallen when she returns. Or Kuandoka, right? She leaves and returns the day to buy a tree. So we ask them, okay, normally in a basic, the average meaning is probably somewhere in the middle between return, the action of returning, or so the action of leaving, and then what's associated with the tree. But if we have context, like this sentence, right? The leaves on the tree will have fallen when she returns. that's going to be closer to the action. And wait, sorry, wrong. Closer to the actual to the tree, right? The physical thing. And so the embedding will move towards the tree. If the sentence is about the actual action, then it'll go towards the action returns, right? And then we give them some examples. There's, some examples of words that have kind of different meanings, blah, blah, blah. So let's go back to Orange and try this out ourselves. So this flow is the basic embedding without the context. I think I already ran it. So you can see leaves is just here. It's just kind of not close to returns, not close to trees, just kind of by itself. But this Python script considers the context of this sentence hapo, right? The leaves on a tree will fall when she returns. So this is obviously related to the tree. So leaves should be closer to the tree here. Is that true? It is. I mean, probably some of it is because of the ordering, but you see leaves and tree, they're close together, farther from returns, right? What if we change the context? What if instead of this first sentence, commented out, we have she leaves and returns today to buy a tree. Run the script. Please don't crash. Oh god. Nope, no crashing. What happens now? Leaves is closer to return, at least farther from tree. So somehow they can see that, right? Okay, question from you, Dom. What if the word tree wasn't there? Does it determine that out? Does it can determine that outcome? If tree, okay. Good question. Let's do a live demonstration. I'm not sure. Ah, so to foot a tree, right? She leaves and returns today to buy a, yeah. Mm, yeah, I guess it's closer to returns. Yeah, that's a good question. Thanks. Hmm. Okay. Okay, so yeah, so people start to get understand embeddings and then how they change based on the context, which we're getting to another Kea, Oleo GPT, right? I mean, we don't go to attention, the KQV stuff, we probably should, but we didn't have time to do that. So the last thing, which is really cool, is next word prediction. So we actually do a little game with them. What we do is we give them this line, what is a spoon, question mark, and in groups, we ask everyone to fill in the next word. So individual people, into moja moja, they just fill in the next word. So they'll fill in pass the paper. The next person will fill in spoon. I mean, it's a child's game, but they get the idea of it. It's really about next word prediction, right? That's all it is in a basic way. So blah, 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 blah. And then we play that game. So they get the idea intuitively. Oh, okay, that's how it works. It really just looks at the context and what is probably the next word based on train embeddings and such. So in Orange, you can kind of also try this, which is really nice. We're going to do the same thing. What is a spoon? Ah, right? That's the quote unquote prompt. Run it. Please don't crash. Yeah. And then what do we see? Look at this. And by the way, this is inspired by 3 Blue 1 Brown. If you know that YouTube channel, this is how we kind of got this idea. So it's a probability, right? It's a probability based on softmax of what's the next word. Obviously, spoon's a big one, and we can choose. Does everyone want to choose spoon, or we can choose another one? Any ideas? Do we agree on spoon? Let's just do one more. It's pretty obvious it's spoon, so we'll add spoon. I know it's a bit manual, but we're adding spoon. Run again. I think it ran. Yep. That's kind of obvious, right? Okay, let's do is. I think we can get some variety here. We'll do Okay. Oops, sorry. Okay, now we can choose. Should we be a tool, device, small piece, or metal? And we do tell them that, like, GPT does tools like that does vary the choice, not always the top choice. There's maybe a temperature and that kind of thing. So, um, what do we want here? Tool? Any ideas? Okay, I will choose a piece of, well, we can only choose one word, right? Listen, do you want piece or metal? Okay, I'll assume piece. Yeah, piece, something. Okay. Okay, what's next? Of, yeah, obviously. I mean, we're getting to the grammar stuff, right? It's okay. I don't know what's next. Piece of what? Piece of metal. Yeah, you got it. Food would be kind of wrong. Wood, plastic, and material is decent, but I'll choose metal. No, I'm not sure if it's going to finish or not. Metal. Run it again. That. Okay, this might be a bit long. I mean, we don't have to finish everything. Maybe a couple more. But you can see how interactive this can be, right? And every student, well, groups of students, maybe two or three, have a laptop and they just kind of do this themselves. Is okay. Used. The widget can be improved. You can also write your own widgets to make it just a little more user friendly, but that's a bit of work that is used to, okay, we'll do one more. It's probably to eat. By the way, this is using GPT-2. The model behind this is GPT-2. I mean, simple, not updated, but, and obviously quite far from perfect, but that is what's generating this number. This is really is GPT-2. I think the small or medium model, maybe medium model. Scoop. Okay, yeah, you get the idea, right? Good. Any questions so far? Okay, if not, I'll do one more example and close things up. I think it's almost time for tea break. Let's see. Yep. Something else we do is not actually we do this is the text NLP stuff and LLM stuff is actually the last thing. We actually start with supervised learning and the basics of a traditional ML flow. And we do things like I think already showed you KNN, right? We actually do a physical game. I think we already saw the picture, but we have cassava leaves which are healthy, cassava leaves which are sick. Tufanya, what do we do about here? What is this leaf? Without telling them anything, we just say, okay, what is this leaf, right? Well, if k equals 1, it's probably sick. What? Lakini, it's obviously, if you use k equals 3, it's probably healthy. So we kind of go through that intuition of what is KNN, how does the model work? And, it's not difficult when you explain it in this way, right? We do talk about parameters, et cetera, but, that's kind of the intuition. We give them a pen and paper activity. They do it. They get a training score, test score. We talk. We do talk a little about the parameters. Not really much math, as you can see, but some intuition. And then we go into orange. So maybe I'll just show you how we do it in orange. This workflow, Hapaccini. Again, these are all widgets. Widgets are on the left side here in orange. There's different kinds of widgets. There's also some are special add-ons. So like geo and text mining need to be downloaded separately. Like you can add on somehow. Where is it? I think widgets. No, options add-ons. Yeah. Ah, but trust me, it's there. Yeah, so you load you load a CSV. This is actually a toy data set, a simple one, but basically it's sleep time, study time, and results. So for students, how much time they sleep, how much time they study, and their result on a certain examination. Most people fail. I mean, it's somehow balanced, right? But the scatter plot is this. It's not real data, by the way. But it's like this. Red is fail, blue is pass, and sleep time is the X, study time is the Y. So you can kind of see, okay, if you sleep a lot and study a lot, I don't know how you would do that, but somehow probably you'll pass. If you don't sleep at all and also don't study, you're probably gonna fail. So that's the data set. First thing about, well, we don't do any data cleaning here, but we do talk about it in previous sessions. First thing for this, of course, you split, right? Train test split. So 80% goes to training. We don't actually evaluate here, but and then we plop in these models, right? So tree, you can see, has some parameters. Da, 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 da. The main one being depth, KNN, number of neighbors. So you tune, this is how you tune, right? You just tune by going in this GUI up and down. SVM has way more parameters you can see, right? And then test and scores where you get your CA, classification accuracy. We do use cross-validation. So let's just look at tree. Let's just tune tree real quick. Oh, whoops. Whoa, okay, yeah. Do this. Close this. Don't think I need this anymore. Yeah. Okay. So let me we'll do a depth of maybe like let's do a high depth. How's tree doing? I'll do 20. 100. Okay. So we're trying to get the best depth. So let's just try to reduce the depth to reduce the overfitting. 841, 841. Can we do better? 842, 844, 847. I know it's very manual, and obviously in code you would probably do a grid search, but again, it builds the intuition, right? They actually do it by they do this on their laptops. They record on a piece of paper in groups, so they kind of just try to get the idea of tuning. So I think 851 is our best one. I think wait, 747, 851, and then it'll underfit. Blah blah blah. Okay, so 5 is the best tree, right? In cross validation, and then you can also there's no test. I don't think. Is there a test? Maybe there's a test. I'm not sure. Anyways, what is another cool thing is you can visualize the boundaries. So I'm gonna go back to orange and go to scatter plots. And this is a really cool way to see what's actually happening when you change the depth of the tree. So let's go to 1. So this is the decision tree, right? It's just making one split based on study time. It was chosen to be the best place to split. And students can see how a decision tree really works visually quite easily, right? Again, no coding. I'm not a fan. I'm not against coding. Obviously, I'm also IT person in a way, but it just helps to get the idea quickly without having to deal with libraries and environments and such, right? So if you increase this to 2, you see there's 2 splits, 3, 4, 5. This is our ideal 1, 6, right? Isn't that pretty cool? I think it's really nice. Same as KNN. You can also have that. I think this is a very high number of neighbors, but let's just do it. Can equal up. Okay, it's here. If you step, let's start 5 neighbors. Yeah, a little more mixed. We'll go to 11. Yeah, 15, 21. Yeah, it just changes, right? Let's go to SVM. SVM is all about lines, right? Lines. What am I gonna do? Yeah, it's a line. I know. Yeah. You can do polynomial. That's kind of weird stuff. RFB, sigmoids. Yeah. SVM is of course more complicated to tune, but we do tell them about some of the parameters somehow. I mean, we could probably try cost, but yeah, it does change based on the cost, right? Not much. Yeah. I think the best one was 1.2. I don't remember now. Okay, so yeah. So yeah, that's how it all works in Orange. Again, it really has been a great teaching tool for non-technical university students who are interested to learn and get the fundamentals, the awareness, importance of training data, why there could be bias, how models work in terms of algorithm in a simple way, how they're tuned, how do we evaluate, yeah, and even how to visualize what's happening. We'll also have confusion matrix, right? importance of a balance there. Yeah. Okay. That's the end of the presentation on Orange. Welcome my team members to fill in anything I missed and any questions. Karibuni sana. Okay. No questions, I don't think. So one other announcement is we are wanting to scale our program to different universities around Tanzania. We started with SUA in Morogoro, and we are in the process of finding people to help us run this program at their schools in the same way. Of course, we can't be at every school every weekend as much as we'd love to. So we're looking for people at different universities who are going to be there next year, starting in, I believe most universities in Tanzania start their first semester again late October, early November. And so we need people to come to us in Morogoro. We train them. It's kind of like a training of trainers. We go through the whole curriculum. We're probably going to go add 2 more sessions, one on neural networks and one on random forest. And yeah, help us bring this really important education to more people on their campuses. So you can fill in this. Where's the link? I'll give you the link right now in the chat. But yeah, full name, phone number, email address, LinkedIn profile if you have it, your campus, affiliation. We're looking at these 3 weeks, August and September. Yeah, so let us know when you're more available. We'll have to see how it will be also with our own schedule, any other comments. But yeah, we really want this to happen. And we want to see who's interested, first of all, to lead this at their campuses. I think it's going to be good for your own learning, for your CVs, for your experience, and for engagements. We really hope to get this really out there to just the more people, right? Because we really see the benefit of that. So yeah, I'll send you the link. Where's the link here? I think this is fine. Wait. Yeah, listen, you're welcome. Thanks for your interest. Where's the link? Hapo. Yep, please fill it in during your tea break. Looking forward to see your responses. Yep. And yeah, that's it from us at Data Safari. Thanks a lot for your time. Really appreciate it. Hope you enjoyed the little quick tour of what we do and in AI Wizards. And please fill in the form. Who's ever interested in leading? And if it's okay if there's more than one person from one campus, we can talk to everybody and see who would be available. Yep. Karibuni sana. We hope to meet some of you and come to Morogoro, and also we visit you on the campuses once you launch the program in your first semester. Okay, awesome. So I think this is time for tea break. It is 10:31, perfect timing. Yeah, thanks, Juma. Sante sana. Yeah, Screw. Really nice to hear these comments. We're also online at Data Safari IO. Okay. So it is time for tea. We'll be back at 11 a.m. sharp for more about the tool challenges. We'll start with Innocent at PAWA and then Fredy at Twiga. And then the rest of the day is just working on those challenges. So no more sessions, comma sessions. So yeah, we'll see you back here at 11 o'clock. Sa Tano Kamili. Santeni.
Hi, are you guys hearing me? Am I
Yes, we
audible?
can hear you well.
Does the voice clear?
Yes, it's not bad.
Okay, perfect. So yeah, let me share my screen here. Yeah, I mean the entire screen. Yeah, so yesterday I showed you about the APIs that we have, and we saw the chat, the create knowledge base, and also the voice APIs, and also we saw how to use it, how to use it, to test different configurations. So today I will just show you how to configure it. So we have this branch called PAWA AI Blueprints Chatbot. It's basically, it has source codes for some of the projects that has been built by using the Power API. So I think you guys, when you actually developing a solution, you can actually use it as, as a reference. So you can actually clone it and actually change it and modify the codes. Yeah, so there is this project called your CFBot. So if you clone this, it's actually in the public, so anyone can see it. So if you clone it, we'll find the backend implementation and also the front end implementation. So the front end is in Next.js, and also the backend is in Fast API. So the backend is where the API for Power AI are here. So you can actually configure your your authentications, the API key, and those endpoints. These endpoints are going to be here, like charts, knowledge base, and those kind of things. Yeah. So for the start, as you can see here, when you actually clone it, let me show you. Yeah, so when you actually clone it, for example, this one, it will be in the front end and back end. So as you can see, I've actually have it in my local PC. So this one, you can actually head it to the YWCF board, and then when you're there, you can see the backends and also the front end. So the backends is where for Python, for API, and also the front end is for the Next.js. So for example, you just want to configure the backend of it, you actually add to the backend, and you will see the codes for backend. So here I am, the backends. So this is how it is. So first thing first, you should create the new environment. So I've already created my environment. Is called .mv power ai.pp. So first of all, you just need to create your own environment, and you're actually using the pp venv, then name of you pass name of environment. Then from that, you actually activate it. After creating the environment, you actually activate it by using source. I think you guys know this, right? So you pass the name of the environments and also bin activate. So I don't know if I'm using the Linux and distro, this is going to be easy. But if you're using Windows machine, I think there is actually a way to create new environments and actually configure it. So after having this environment, just install the requirements. So this is the requirements. As you can see here, is the most important requirement is basically the mat part for processing the documents and actually sending the images and multimodality, because also Power support multimodality. And also the other requirement is this one, HTTPX, for sending the request to our servers, to our endpoints. Of course, the Fast API for launching the server and have this server configuration in the press. So then after that, after creating the environment and have have your environment ready, you can actually install pp pp install. You can actually go on pp install. Then you pass the name of the requirements. So if you install this, it will actually install all of the requirements, right? Yeah. So if then from that, I think the project will be ready to work out. So you can actually start your server by Python. So I'm actually using Python 10. That's why it doesn't matter. Just any version of Python, Python 11, yeah, or just Python. I don't know. So for some reason, I have to write Python 10, 3.10 on just my configurations. So if you start the server, it will open to the port 80,000. So this one, and you then from that you actually go to the so this is the configuration of backend. So from that, everything will be up and running. Then the other thing I think from backends is basically the .env. So for the .env, you just put the name of the host, the IP address of the host, also the port you want, and most important, the API key. So this is the API key. So the API key for now, we are going to use my own API key, because all of these features are in the preview phase. So you don't need to, charge or pay for something. Everything is free just for you guys to test it and actually give us feedback. So for now, we are going to use my API key. It's free. I just have the master base account, so I don't pay for this for now. Yeah, also the name of the model you want to use. So we have the Power Base. This is what I showed you. I mean, yesterday. We also have this, the simplest one, I mean, the smallest one, it's called PAWA. So Ember means small, like fast, it's very fast, it's very small, but this Braze, it has a lot of capacity, a lot of capabilities. So like things like listening and also coding. I think you guys, know functional coding, like how do you make your model, how do you leverage this capability in these LLMs to be able to call different functions. So you can actually create your own functions and the model will be able to invoke it when it needs to invoke that's, I mean that functions. Yeah, and also we have you actually put the system prompt. So system prompt, for example, this is like jina lako ni WCF agent, msaidizi wa kirafiki aliyeundwa blah 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 blah. So guys, like what does your system, like what do you want the power to behave, like the name of the of it, like how maybe it should not talk other things apart from the topics, or maybe it has to behave, those kind of things. So it's you basically write here in the power system prompt. Also configure different temperature. Temperature is like how likeness the model should focus on the, how likely the model should focus on what he has told, or maybe does it have to think a lot or like add some sort of fit. So the more the temperature is, the more you allow the model to actually depends on itself. So it will have this ability to add some contents. So there is a lot of difference between the context, your lag, and also the actual response that are provided by the model. But the small, you actually tell it that just focus on the context. So there's no kind of genius around it or like smart kind of things. So the top P, actually the tool choice. So the tool choice, as I told you, for the model like Braze, it also accepts the tools, the function calling. So the tool choice is basically to tell the model like how do you want how that model will do, so as to choose the tools. So for example, if you say required, if we pass required as one of the configurations, what does this mean? It means that for every request, the model will go there and check the tools available. So after checking the tools available, it will try to answer that questions based on the tools. But if we change to auto, so we are safety required in auto, it means like it become like kind of if else. So the model itself knows whether does it want to use the tools or not. So if it finds that it wants to use the tool, then it will actually call the appropriate tool and actually use that. But if not, then and also the maximum token, what do you want, like the input and output, the kind of token limit that wants the model to process. So if like you have the model required to give a large output, I think you can actually increase. So for now, we have almost up to 800 token limits, with I think, this is very enough for basic activities like 2 or 3 books, I think. But if you don't want, the more limits, the more token you have, the more the model can actually. So other providers are basically charging to the limit. The tokens, what tokens the input and output model processed. But for us, we are basically not charging based on the tokens, but we are charging based on the how much amount of requests have you sent. So maybe during the day you could send maybe 10 requests to our servers, and then maybe just one request have almost this kind of token, like 100,000 tokens. Then we don't care about the tokens. The models are produced. We care about how big your request is, how likely, how many requests have you sent to the server, and like how activeness you have, and so if you're not active, then like we're not going to charge you. But for other models, you can be like you're not active, and maybe you have sent almost just one request, like, but it has maybe tens of maybe tens million of tokens. So that's also will be a problem.
Innocent.
Yes.
Can you share that API key, please? Because mine, I don't see it.
Yeah, I'll actually share the API key. Yeah, I'll actually share the API key.
The
So
same one
this
from
one-
yesterday, right? Ilya Jana.
Yeah, I sent one for yesterday.
Yeah, I can
think
copy
I'll
it if I have the. I have it, yeah.
Unfortunately, I didn't see
Wait.
it
I'll
myself.
share it. Yeah, so there is also this configurations to the backend. You can actually, it was called the KB reference ID. So KB reference ID, What it means that I think you guys know about lag, right? So in LLM, so I mean in AI, there is something called lag. So lag is basically the methods which give us the model ability to know your external data. For example, here, if you don't pass this one, I mean the model won't be having the external knowledge about your data, and actually it won't be able to answer the question that led to our data. So how do you do that? We basically use the lag to give the relevant information, relevant knowledge to the model, and the model will be able to answer the question based on that knowledge. So for us, PAWA, we have implemented this kind of no code kind of lag, whereby first of all, how do you get it? For the backend, you must, as I said.
Sorry, innocent. Somehow innocent. We don't see your screen anymore. Are you still sharing?
Yeah, I'm sharing the screen.
Unfortunately, is it visible?
Is it visible?
No,
Why?
on my side not.
It was, right? But then I think it's, can you please try again?
Let me share it again.
Yeah, thanks.
Yeah, now it's
You can see my screen, right?
exactly.
Yeah, sure. It's visible.
Yeah. Is it visible now?
Yes, we're good.
Okay, fine. So, okay, where I was, I was here. So, are you guys see my screen now? I'm the .env configurations. Can you just confirm you see my screen? I've just opened the VS Code. You guys see the VS Code?
Yep.
Hello? You see it?
Yeah, exactly.
Yeah, so there is, I was talking,
.env.
yeah, I was talking about this, the KB reference ID. So if you want this model to understand, maybe if you have data, like the external data, and you want the model to understand, I mean, your data, so you actually create this folder called data, and then you put your documents. So you can put the PDFs, you can put the docs, you can put the text data, you can actually put the audio if you have the .wav, maybe if you have maybe even the image. For example, if you have the image, if you have the audio, you can actually put it here. But for the this example, I just put the PDF. And
does it support audios as well?
Yeah, it support audio. So you can put the .wav, .mp3, .mp4, those kind of things. Yeah, so you can actually build the knowledge base by using the audio. I think that's very important. That's very one of the amazing things about this one.
Yeah, and innocent. I think I'm just talking to Dr. Model. This is the best place to start, right? For anyone doing the challenge is here.
Yes.
This is the best place to start with the challenge.
Yeah. So this is the best place to start. And these are actually the blueprints. So you can actually change it, anything. You can actually, take these codes, try to modify it, try to put different capability if you want. I'm trying to show you like how can you do that and explain different parameters and how do you configure it. But for you guys, you actually do it yourself. Yeah. So where are you going to get the KB reference ID? You basically, there is this file. If you head over to the backend, so
I would love to know the text, the coding editor you're using. Mr. Innocent.
Yeah, it is VS Code. VS Code.
Okay.
VS Code. Yeah.
I had the same question. Thank you.
Yeah. So you basically learn this script called generate.kb, and then person note. Okay, my bad. It is supposed to be Python. Yeah. So what's happening here? We are basically taking the documents that are in this folder, and we are actually technicality do some sort of extraction, and also after doing this extraction, we do some sort of chunking. So for every document, when you get the textual data, we do chunking, and for the chunking, we do also embedding. So we store those vector DB to our server, so you don't need to worry. Then from that, we'll turn you the KB reference. So for every request, you basically send this KB reference here. So from that, the model will be able to understand. Then from that, the model will be able to understand to incorporate your external knowledge to the PAWA model. But there is something tricky here. There is this parameter called is must KB. So this basically means that, as we know, for traditional lag, for every request you send, you have to do embedding. That's what other frameworks are doing. Like
yeah, exactly.
Llama index, for every request you send, you have to do the embedding. But for us, we have implemented this parameter called is must KB, which basically trigger if you want that feature, like whoever requests to do as embedding, or maybe you want like to be kind of maybe directional. So we have tool called the lag tool. What about the model? We have actually directed the model. That tool direct the model whether to use the lag or not. So for example, for the request like Mambo, we're not going to build embedding around the Mambo because that's general. Doesn't I mean it doesn't relate to your knowledge base. Doesn't relate to anything. Just Mambo. So we're not going to charge you by just Mambo. So from that, the model won't be able to use. But if we pass through, then we're going to do that the traditional one. But if we don't pass this one, then it's going to be agentic kind of things. So the model will know itself whether to use it or not. So that's also, the beautiful thing about PAWA. So like all of this capability are already being made, so we just use it. So we have also configuration for, the voice, the audio part, what model is available, the maximum token, the temperature, and also for the SST, speech to text. Speech to text means you have the audio and you want to get the text around that audio. It's called transcription, the ACR kind of things. So yeah, and then let's head over to this is so this is the front end. If we clone it, you can actually, as you can see here, this was the back end, this was the front end. So just head to the front end part, and you will see the codes for, the code for Lonny, the code for Next.js. So we are going to implement for Next.js. You can change it from React, whatever the front end you want. This is just the demonstration. So you can even pip install, just install the package, and then after that, then what also happen? People learn in PM front end. I don't know what's happening. Yeah, so you can actually learn the PPM. I don't know. Is it npm? Npm run install, or in the different.
npm install. Try.
Npm install, right?
Yeah.
Yeah, I think when you're doing demonstration, there is a lot of manual. So for me, I've already installed it, but yeah. Then from that, you just start the servers, like npm run dev. So the server start this port. And you can do a lot of configuration, like changing, because here it is connect to your backend and also connect to the front ends. Then from that, I think you see, actually see, the codes that's happening. So this is the UI. After when you start the front end, you get this UI. Are you guys see my screen?
Yes,
Yeah,
yes, we
sure.
do.
Yeah, so this one can actually start new chat. So this is the UI. So you can actually talk to the model like this. Some of the issues here. So request, what's the problem? Sort of problem. I think I haven't. There is actually a process to the servers, but I think actually have to check this. Yeah. Yeah. But you from that, I think that's you should be able to learn it. I think there's some of the errors to the server. I don't know. I'm sending the bad request to say. Aha. Okay. So the test that is here. I'm going to process the request. So there is actually the server done the configuration here. So yeah. So but from that, I think. So the idea was should be able. So we should be able to have the access API key, and also be able to have this API reference. Then from that, you can do anything. So just take the code and modify it, and also I think also that's will be part of challenge. Make it work, make it learning, right?
Yeah, sure.
Let me try to start the server again and see if we have something works here. So, and also, I just want to say that for this challenge, we certify, we are going to give 200K, 200,000 Tanzania shillings for someone who will be able, I don't know what the first, I don't know, the price for the first one, but Mr. Lonny, is that okay with you? Like, I just want to give you something to someone who will be able to figure out all of these stuffs and actually
Yeah,
get
that's
something.
amazing. Of course. Thank you so much. Yes.
So I will actually provide it myself.
Okay.
For the person to be able to build
Guru.
just do anything with
Good
power.
motivation, Nazani. Thank you so much.
So I provide the Lakimbili, for the someone will be able. So if you really want that, you can actually check me. I'll give you the API key, the access, even technically to help you. And then from that, you can see how you guys can actually going to use it. I just want to see builders. I just want to see people who can build it. Yeah. So let me start the server again, and actually here I think.
Innocent, there's a request to zoom your IDE. They're saying they want to see it larger font, I guess. Possible?
Yeah, the larger font.
Just to zoom in a little bit in your IDE. Yeah, maybe a little bit more. Yeah.
Okay. I don't know. I'm just using Mac. I don't know.
Yeah. Maybe put a view. I don't know.
Yeah,
that's better.
Okay. Let me check if it's
Thanks.
running. Let me try it. Okay. There's still some problem. Yeah, I don't know. Still some problems. So I think there's some problem to the to the server. Is a lot of congelation here. We actually fixed it and put it to the template, and you guys will be able to learn it. There is the bad request is sent all our parts. So the bad request is sent to the servers, and I don't know what's it was here. It was learning. Oh, this is
It looks
now.
like an internal server error.
So I think, you send too much token, and you put so just, you put 128,00. So I think the maximum you can.
Oh yeah, that's calculation. Oh, thanks, thanks a lot. Thanks a lot. I just. Where is it?
Yes, they are in max tokens.
Oh,
so
yes.
remove.
Yeah. Oh, thanks so much. I'll try to put the maximum token. Yeah, this one there also the KP. I think I just. For now, let's just use the not use the anything. Then I think. Yeah, so from now, let me start the lower part of it. Once what go, yeah, I can, yeah, that should be going. Yeah, so let's start again. Top the server and see, okay. Yeah, so this is what we have. So basically, it's basically connecting the front end and also the backend part.
Wow.
And that's see actually going on. So you can even preview the audio because for some reason
Oh, that's nice.
there are people. I think you guys can you listen to the video? I don't know. The voice.
I can hear you.
Yeah. So then from that there is other capability. I don't know. Yeah, you can even sense. Yeah, you can even send the different documents if you want. For example, maybe. Yeah. Yeah, so from that, I think you guys will be able to have, so you have all of this capability, you have the audio to text, you have the text to audio, you have the chatbot, you have the model that understand tool. That means you can actually put your own tool. Maybe, for example, maybe you're implementing the payment system, and the model from the queries, the model will be able to, send that systems. What can you do? What can you just so it will be able to answer and actually give you, yeah. So I think, so we are going to, just give 200 Tanzania shillings for someone who will be able to incorporate all these features. Very good, clean to production grade, like the audio, the, tool model understanding, be having this actionable tool, actionable system whereby the model will be able maybe to make requests to the external server and maybe, for example, register systems. Right now, most of the other providers, or maybe I don't know what the stack you're using, but how does the system is going to register the real-time users? Maybe check the logs to the user. Maybe someone stuck, for example, maybe someone stuck to the to the system, and maybe it took the screenshot of that problem and upload to the chat. The chat has to be able to go there, open the database, and see the logs, everything, even actually do that thing on behalf of the users. So that's very important. That is what we call the actionable bot. So you're actually slowly moving from the just chatbot to actionable bot, the bots that can actually do some actions. That's why you see tools like things like agentic, things like tool, things like MCP. And when these companies will be, maybe the future, like this company will be able to provide their MCP, maybe MCP for Tigo, MCP for maybe government and government agents, MCP for what? So these powerful systems will be able to connect to those kind of things, and having this wealth of knowledge to actually do something actionable. So you need to add value to the user, and not just like the chat and like mambo power, what is that, but also the actions. Maybe open the account, maybe send this money to this one, maybe troubleshoot these kind of things, maybe check my code, maybe push it to to the GitHub. So those are the actions. It's not just like mambo power, like what is that? No, it's the actions. So that's where we're going. And for us, PAWA, we are trying to make it more easily to build those advanced actionable chatbots. And I think with PAWA, that's where we are going. And yeah, I can't wait to see what are you going to build with, all of these technologies at your hand. Thanks so much.
Wow, thank you, Innocent. I mean, that's really the next level, right? This agentic AI,
Yeah.
and yeah, like the beyond just chatting. Wow, impressive.
Yeah.
Welcome questions while we still have Innocent here.
Maybe Innocent can drop his email on the chat.
Yeah, Innocent.
Yeah, thank you. Let me just drop the email.
Great.
Yeah, so that's my email, and also my WhatsApp number. If so there's this question: which tool was used to develop the UI? So we have actually used the Next.js. So that's Next.js brush motion library or motion library for interactivity. Yeah, so there's also this question: do you offer training programs for beginners who are just getting started with AI? Yeah, we do also offer programs, and I think here we have we have these people interns. We have also people coming from field. They are here at office, so we also have that. I think we can actually include to that program, like how do you understand these things from from the core. For example, a lot of people know lags, but for some reason, when we ask them what's lag, basically is, they tell you about Alama index maybe, or maybe LAN chain, but technically what's going on inside the lag, what was the purpose of lag. So there are those kind of basic things that people have to know or not. So can you organize training for beginner, please? Yeah, this is very good. I think we'll plan that, and so we'll have that for for the coming for the coming quarter. We'll actually have it. and we'll see how it's going to be. And yeah, we're going to announce it. Yeah, can also share the GitHub repo. Yeah, the GitHub repo. This one, the GitHub repo, this one.
The blueprints chatbots, right?
Yeah, the blueprints. So the blueprints chatbot.
WCF bot, yeah, okay. WCF was your example, okay.
Yeah,
I see.
if you get stuck anywhere in the code,
That's
just
great.
check me through the WhatsApp. I will actually be able to answer you. So don't worry. And yeah, so if you get anything stuck, if you need any help, maybe any assistance, or something doesn't work, just check us and we'll actually fix it. We just want to see how are you going to build how you're going to use the technology, power technology, to build a cool solutions. And the most important, like the actions, like the action around it, this capability of, for example, the audio, the voice, as you can hear, like we just train these things from scratch. So like there's no kind of maybe English voice kind of things. So it's basically natural to Swahili, Tanzania or Africa. So I think that's very amazing. If a product, and actually it's locally in Tanzania, I think locality is very important. Like the system that actually can talk, can actually see, can actually understand like how we Tanzania people do. So they say that's very amazing. Yeah, another question, please. So we hope you guys will. Okay, this is Michael Morel. Yeah, we also need ambassador for the power. The idea is we really want to localize how AI. The problem is AI is getting more advanced. AI is getting more advanced. There are other providers like OpenAI, Anthropic. They have a lot of advanced features, but but the problem is they do charge a lot. Like I think you guys, you can actually, maybe you have been witnessed that. Like these guys are charging a lot from the embedding, from even chatting, like the tokens, because they do burn GPU a lot. So we saw that opportunity. Maybe we could actually having the platforms with all of the advanced features, but we don't need to charge more to our people. And in order not to charge more to our people, you have to make sure that you reduce the cost of production. So we saw the opportunity to the small language models. So we're actually working with the small language models and technicality, how to make them more advanced. And actually, if they become more advanced, that means they want to cost us learning it in the productions, and then we can actually charge less to all of you guys. So that's where we are heading. So the physical locations, we are actually near Mbezi Beach, near Mbezi Beach. For some reason, we tend to use Mbezi Beach because a lot of people don't know Mbezi Beach. Mbezi Jew. So we are in the Mbezi Beach near beach. Yeah, Mbezi Jew near. So yeah.
Okay, nice. Yeah, and Innocent, you'll be here around tomorrow because tomorrow is when they'll do the presentations. Let me just share the program for tomorrow. After the careers panel, each group will share their solutions to your challenge in the morning. We'll have tea break, we'll have poster competition, and then the announcement of the awards will be in the afternoon.
Yeah, I think I'll try to make it. I'll try to make it.
Thank you so much. Yep. Yeah, we also need you to judge.
Okay, perfect.
Great. Okay.
Perfect.
Thank you, Innocent. That was great. That was excellent demo.
Yeah, thank you.
Yep. Okay, thanks, Innocent, again. Now it's time to welcome back Fredy for Twiga.
Lonny,
question. Oh, we have a question? Sorry?
Someone,
Dr. Molo.
Not me. Someone rose a hand. I think user something like that. Maybe. Okay, it disappeared anyway.
Might have been a clapping. I'm not sure. Yeah. Any last questions for Innocent or Dr. Molo for PAWA? Okay, going once, going twice. Nope. Okay, then in that case, we'll move on to Twiga now. Fredy, are you online?
Hello, can you guys hear
Hey,
me?
Fredy. Yep, we can hear you. Welcome.
All right. Give me a moment. Can you guys see my screen?
Yes, sir. Llama Cloud.
Okay. All right. So first thing first, this session is on the support. So first I'd like to ask if anyone had any issues or did anyone get stuck anywhere so that they can maybe try to focus on the specific area which people are getting stuck on, or is there any question concerning the challenge? So you can just send the questions in the chat, or you can just unmute. Apart from that, just a quick reminder on some of the things which we had to do yesterday. So the first thing was to create the folder for the input papers and the vector store folder. So maybe let me just show it again. Because oops. Okay. Yeah. So it's just giving a reminder. You have to manually create this folder, the input papers folder, and the vector store folder. So that was the hiccup which we saw when we were like trying to start it up together. And also another key thing which you'd have to address is to change the directory for the papers. So I think that's in the processing. Yes, here. You have to change this directory. So that's those are the things which you have to like take into consideration before you actually start running, because it might fail if you don't update this to the actual path inside your computer. And to also get the path, so since you have just created the input papers directory and then you also have the papers directory, all you can do is you can right click on the folder itself. So for the first one, it's the papers directory. You just right click on it, you say copy path, and then you're going to get the actual path which you would need to keep. All right, the actual path which you need to keep. And the same thing goes for the output directory, which is the input papers. So after you've created the directory, you would have to right click, copy path, and then keep that path there too. Then after that, everything should run accordingly. Another thing which I would like to address is how are we going to how are we going to evaluate maybe the parsing? So I have been, since there's a suggestion yesterday to find like an automated way to maybe to be able to see how accurate the parsing is. I'm going to update you guys in terms of like a tool to use to maybe get a proper, let's say, proper score on how your past content is. But as of now, you can have a look at this. Let me share this. As of now, you can take a look at this. So you can look at the text accuracy. So you can look at the actual PDF, the papers, and then you can look at the markdown of the past content. Then you have to see if there may be key information which are missing, in your Markdown file. So this can help you know that maybe I need to maybe update the prompt or update some temperature and other parameters to make sure it's actually picking up all the information. Another thing is structure, kind of like the headings, the paragraphs, and etc. So of course, this means the heading, the listings, tables, and basically overall structure of your Markdown. So as long as you at least try to hit to get your structured output according to these criteria, I think that's going to be the key things which are going to help you perform well in the parsing challenge. And also the way you're going to give a score is maybe from 1 to 5 according to the specific criteria, right? So that's how we're going to basically somehow judge that. Yes, I see someone had a question, right?
Sure, I'm sorry. Yesterday I tested on the passing action of this project of this challenge, and I tried to put a PDF with very complex mathematical visualizations and equations. Unfortunately, it's mostly performed, and maybe to say it's not performed well. So that's criteria means we are going to find a way on how to present it nicely, or what is going ahead.
Okay, so that's pretty nice as long as you've been able to actually give it a try. And also, you say you didn't get good performance on a PDF which had some mathematical content. And yeah, usually parsing papers which involves a lot of mathematical equations and what's not, and can be a little bit challenging. But we can assume Llama Parse can be one of the best options for you to be able to parse such content. Now, what you can do is you can, again, as I said, you can try adjusting some of the parameters to make it really, to see how is it performing, right? And maybe one other thing is that in the papers, we have provided these 3 papers, and they don't have a lot of like complicated information or whatsoever. And of course, you can try using another document and everything, but I would advise for you to just stick to the papers which have been provided, because we've been trying to not make it that much challenging. So yeah, so if you tried a new paper, it's good just for the sake of learning, but I would advise to just stick to the papers which are provided in the repository, so that it cannot be that much complex. But yet again, if you wanna try to actually improve or learn better, you can even try exploring the other papers, and you can reach out to me directly. I can give you more hints on that. But for now, let's try to make sure everyone gets maybe good information to help them be able to complete the challenge specifically. Is there anyone else who had a challenge? And also, Juma, did you manage to run the full notebook until you got the last outputs using the existing papers?
Yeah, exactly. I do.
Okay,
It's run perfectly, and you had that's a big key from Llama Parse and the Parse into the notebooks, and everything was fine. So, yeah.
Okay, I'm glad to hear that. All right. So those were the key things which you have to maybe take into consideration. Just use the existing papers which are here. Also, make sure you have created your directories. And I think if you haven't pulled the code yet, there's a commit I'm going to push, which is basically going to make sure these directories are there when you pull the code, so you don't have to manually create them. So if you see the directory, the input papers, and the vector store, you don't need to create them again. But if you don't see them, that's when you're gonna create them. All right. Are there any other questions?
Fredy, small question. So the inputs are just these 3 papers, right?
Yes. The inputs are just these 3 papers. So even when we're trying to see how good your parsing is, we want to see how the outputs of these 3 papers are going to be, the markdowns, right? According to those criteria which I just showed. I'm also going to send a link to that document in the chat so you can be able to see them. And yeah, so if you
So
focus
that's the metric. Okay, got it.
Yeah.
Thanks. Okay.
Also, something else which is key is when you go to the RAG notebook, you're going to see there's a place where we have these test questions. On purpose, all the test questions are focused on one paper, but you should change the test questions to actually test throughout all the papers, right?
Okay.
Ask questions which are going to be involved in all the papers, since when we're trying to judge is we are going to have we're going to have a secret list of questions in which we're going to ask.
Yeah.
Then we're going to see how
Secret.
yeah
Yeah,
we're going
got
to
it.
see
So
how everyone is going to perform on those questions. So it's maybe your work to try different questions and then to make sure you're actually performing good in all those questions. And again, the questions are going to go through all the 3 papers which we have here and nothing extra.
but similar kinds of questions as to what we see here, right?
Yes, yes. It's going to be similar questions there. So it's going to be kind of like what is this? How is this? Explain about this. How was this addressed? Questions like that. You see, kind of like list the main references cited on the paper. For example, here, what are the main diseases? How is the data set for training and testing prepared, right?
Okay.
It's going to be like
so
that.
That's the ML one. Okay. Yep.
Yeah, but also since we want to be focusing on like all the 3 papers, in some questions they're going to actually like point out a specific paper, right? And since of course these questions, as I said, they were just trying to focus on one paper. So of course this kind of question, it will be best suited for it to be something in the maybe specific paper. Let's say in mobile-based deep learning paper.
Okay.
Right? So it will be something like that. So it might try to specify that. And the reason for that is we're trying to see when you actually ask that question, is your RAG pipeline actually going to get the specific sources? As you can see, it actually says which sources it used. So even when you are actually testing, you're going to see, oh, maybe that question really used a specific like paper. And I think this might be a good time for us to actually give that a try. So here's the question maybe we want to focus on. Actually, the code is actually testing only the first 2 questions. So just keep this ahead. Actually, don't try to focus on testing a lot of questions, because depends on the kind of like your LLM provider and the number of tokens which you can get. So you might easily exceed those limitations. So that's why over here I just saved the first 2 questions, right? So how's the data set prepared? Deep learning paper. And then maybe we can ask the same question for another paper, right? So now we have the first 2 questions. Then we can try to run this.
But you recommend only sending 2 or testing 2 questions at a time?
Yes, I recommend that, but of course you can go to 3 and etc. But I think 2 questions at a time is fine. And also, when you run all, for example, it didn't run since yesterday. So after you run all, next time you won't really have to run all the cells. You can just run from from the cell which is actually like initiating the call. So that can be better.
Okay.
So, let's get that. So basically you can run from here going down. But since last time I ran this was yesterday, that's why I just
Okay.
I just
It's like a notebook cell, right?
Yeah. So yeah, so here is, you see the comment says, how was the data set for training and testing prepared in the mobile-based deep learning paper? So this is the question which we asked, right?
Mm-hmm.
And then, yeah.
Pager. Let's see.
The answer, provided text mentioned data processing involved 3,000 images. It's not detail specific of how data set training is prepared. Right, and then you can see here it's the sources which it used. So it actually used the banana disease paper and also the machine learning the practical machine learning paper,
Yeah, more
right?
intelligent.
So yeah, so these are a few things which you could see how are you going to improve on, like always trying to use the right sources. So maybe this would be an issue in the prompt to actually like let it know should focus on the right information. But yet again, it could even use other sources which are not really like helping in answering, but then the actual result can be a good result. So the final thing which we're actually looking at is mostly considering is the actual result, the actual answer. So yeah, so I guess for this kind of answer, it can be a good answer since maybe in the paper itself, it didn't actually say how it was prepared, but then it did say that the images which were involved. So again, it's good to actually go through the papers and then know the good questions to ask, and also so that you can be able to know if the actual answers are actually making sense or not.
Okay, so it tells you which chunks it's using, right?
Yes,
Okay.
yes.
Okay, I see.
So the other thing is, of course, you can also see here, because here's the first chunk, and then it says it was from which paper. So you see, for the second question, it actually just used the banana disease paper, right? Both of the chunks were from there. And the sources was just one, right? So you can see this second question, it was able to perform a bit better, right? Yeah, so that could be a very good hint in trying to do better in this. And maybe throughout, or maybe tomorrow, I could even maybe in the morning send you some maybe hints in terms of like test questions, which are not the final questions, but the questions which I'm expecting you should get like good results on. So maybe I can also help with that. So yeah, are there any other questions? If not, that will be it on my side. And again, you can be able to reach out to me anytime. I think I should.
Liston's asking for your contacts. Is that okay?
Yes, yes, yes.
Yeah.
Let me share that.
Let's see how many calls you get tonight. I'll also try this. I wanted to learn and try.
You're welcome.
Something. Yep.
I sent my
And you'll be
email
around.
and
Sorry, go on.
I said I sent my email and phone number on the chat. So
Yep, we see it.
see
Nice.
that.
Thank you very much. And you'll be around tomorrow morning for the presentations?
Yes, yes.
Yeah, we have a career panel 8:30, and then 9:30 will be the presentations, and then we'll announce the winners in the afternoon. Very exciting. Nice. Yeah, thanks, Fredy, for setting all of this up, and coming online every day, basically to give us more, a little bit more and more about what to do for the challenge. I think it helped a lot of people.
All right. You're welcome.
Yeah. Any last questions for Fredy? Okay. If not, then that wraps up today's program. The rest of the day is really for people to work on the challenges. They can do it in groups of up to 4 people, and there will be prizes for the winners of this challenge as well as this challenge as well as the one from for PAWA. We'll announce what that is exactly, but it'll be related to learning more about machine learning and AI, of course, and other good things that you'll like. Yeah. GitHub link from Caleb. GitHub link. I think we have it here, right? No. GitHub link. Fredy, can you share the GitHub? I can also try to. Yep, thank you. There you go, perfect. Okay, stopping recording.